All right. Well, for one, hello and welcome to the August 2023 Algebra 1 live stream. So I will wait a few moments for people to join in, but we are doing the August 2016 test. I figure I'd go pretty far back so that people, are less of a chance that they have done this specific Regents. So I will give people a chance to either, download this, print it out, whatever, and that way you could follow along as I go through these questions. So just one quick note here. The calculator that I will be using is the TI-84 Plus CE, and I'm going to reset this. I'm going to hit second. The plus sign is where the memory is, and then 712, because if you are using your own calculator or borrowing a calculator, if your school does provide one, it's important to know how to operate from like the initial setting on it. And if you want to just reset it back to factory setting, that's fine. But that's where I'll be starting for this particular live stream. So I'm just going to monitor. Oh, we have people in the chat. So I see we already got some comments. I'm sorry to hear you're scared for tomorrow. It's normal to be nervous or scared. That means you care. But my best advice for that, if you want to talk about like the mental aspect of taking a test like this, is to convert that anxious energy into like actual like energy for you to take the test. Okay, because I know like when I would be ready to take a test, I know it's been a long time, about 10 years since I took like a serious math test. I remember I would be anxious, but then once the test got closer, I would just say like, all right, here we go, like let's just do this thing. This is gonna be all right. And I would kind of like hype myself up to just like kind of get the ball rolling there. So hang in there, you'll be all right. Do your best to stay positive. I like that advice. So at Elijah, do your best to stay positive here, because at the end of the day, it's a test. I know you need this test to graduate. So it has a lot of weight, depending on what grade you are, you're in taking this test. But it's just, at the end of the day, it's just a test. It's not the whole picture of you as a student. It's one day. It's just a little slice out of your whole math career. So, just do your best on this thing and you'll be all right. So we have 20 people already. So once again, the test that I'm doing is the August 2016 exam, as I said in the description. So that is what I'll be going through for this. I'm sure that question might pop up a bit. I did put it in the description, I believe. So hopefully that the 2023 one, no. So I always appreciate a little bit of humor, but I'm not going to throw away my whole teaching career to leak a copy of the Regents. I don't even have the Regents. I'm not even working in summer school, so I wouldn't even have any access to it. Very few people have access to those tests. They keep them pretty secure. So you're better off just staying at the live stream and learning it, this way. So first up, let me see. I'll wait till it is exactly 8:30. So I will keep to my word. We have a lot of stuff to get through, so I guess I'll just get rolling here. But first up here, we're going to be doing the multiple choice. And the first question here right away, what do we have? Let's see. The graph below shows the distance in miles m hiked from a camp in h hours. So which hourly interval has the greatest rate of change? Okay, so greatest rate of change. For one, the rate of change is the slope. Okay, and the greatest slope, you're looking for, in other words, which line segment is the steepest. Okay, so which line segment here is the steepest? Okay, so that's the main question. Which line segment? So I'll write that out. Which line segment is the steepest? Because I want this to be, educational. I'm not going to go through this at hyperspeed. I want people to actually, get something out of this. So which line segment is the steepest? And I hope I'm spelling this right, but it's not an English Regents. So imagine you're, there's you. I'm so happy that you're learning math in August. And, you're going to climb up this thing. Where would you struggle the most? Assuming you're not a super athlete that never gets tired. You would struggle right here from 0 to 1. Okay, so this segment right here, this is where things are the steepest. Okay, so from 0 to 1, this question here, yeah, is just, it can be easy if you know what it's asking. Because yeah, which one is the steepest? Which one would you struggle the most to climb? Like, isn't too bad. But you have to know your vocabulary. If you don't know the vocabulary, then it's really tough. All right, question 2 is a little bit strange with how they worded it, but the solution of an equation with two variables x and y is. So I'm just going to make one up, an easy one, like y equals x plus 1. Okay? So, and I'll just plot some points here, like, or I'll just pick out some points, like 0, 1, 2. And now I'm just going to do this x plus 1. So 0 plus 1 is 1. 1 plus 1, first day of school, is 2. 2 plus 1 is 3. 3 plus 1 is 4. So now look at the answer choices. The set of all x values that make y equal 0. So no, that's not it. That would be the roots, maybe, okay? You could say like the roots of a function. So this would be more, once again, talking about roots, not the solution of an equation. So the set of all y values, actually, I'm sorry, yeah, that make y equal 0. The set of all y values that make x equals 0, those would be y-intercepts. So same idea, like this one's no good. The set of all ordered pairs x, y that make the equation true. Well, there it is right here. Okay, all of these x and y values make this true. Like if I do, 0 plus 1 is 1, 1 plus 1 is 2. So that's what the solutions are. 3 is already looking good. The set of all ordered pairs x, y where the graph of the equation crosses the y-axis. This is the y-axis. If you think about the y-axis, is where you're on like when x is equal to 0. So that's kind of like the same thing as choice 2. All right, so that's why 4 is no good. So definitely choice 3. Now, one thing I want to point out here, I think back, I've been teaching now 10 years, and I've taught, plenty of students, some students like just so amazing at math. And anytime I have a student who does like exceptionally well on a Regents, like they get like 100 or something really high, I ask them like, all right, what's your secret? How do you do so well on test? And I remember like one student saying that they look through the wrong answers and see like, why are they wrong? So it's one thing to be able to get the right answer, but finding the wrong answers and like being able to say why they're wrong will like really up your score. So just try to be able to do that, I guess. Okay, which statistic cannot, so there's the, watch out, there's a bear trap right there. All right, if you watch my other videos, you know all about the bear trap. All right, I don't have one that's going to roar right now, but just be careful because you're more likely to find one that can be determined. Which statistic cannot be determined from a box plot representing the scores on a math test in Mrs. DeRitter's algebra class? All right, it's an interesting name. Okay, so here is a box plot. Okay, so this is just a random one, but you have to know what each thing represents. Okay, so this one here is the minimum value or the lowest score. So this is out because we can determine that from a box plot. This one here is the maximum or the highest score. So this we can determine. This here in the middle is the median. Okay, so this is the median. So we can determine the median. So just by process of elimination, it has to be 4. The score that occurs most frequently. And if you know the vocab for that, that is the mode. Okay, so the mode is the one that shows up most frequently, but the box plot will not tell you that. Okay, so yeah, min, first quartile, median, which is your second quartile, and then this is like your third quartile. Okay, so this is like, Q1, and this is Q3. All right, the interquartile range. So I'll write down some other terms. So the interquartile range is Q3 minus Q1. Okay, so that's just some stuff to know. All right, so just being mindful of that. Oh, I believe I provided a link in the description. So yeah, this is August 2016. Yeah, I would not give away the answers to tomorrow's test. Maybe if they paid me like $10 billion, like sure, I would lose my job for $10 billion. Like if I could retire comfortably to make, all 29 of you very happy. So to anyone just joining, like welcome aboard. Thank you for supporting the live stream. We're doing the August 2016 test right now. So yeah. I'm going through an old test because that's the best way to get ready for a Regents at this stage of the game. Just practice as much as you can, practice test. So which chart could represent the function f of x equals this? So now I'll go ahead and use a calculator. So notice 0, 2, 4, 6. They're all going 0, 2, 4, 6. So let me pull up the calculator here. So let's see. All right. So now I'm reset. I'm going to go to y equals, and I'm going to write negative 2x plus 6. Because I don't want to play guess and check. Like, we have a calculator. We might as well use it. And now I'm going to press second graph and go to the table. And I will just take a quick screenshot of this. Okay. So there it is. All right, we'll shrink this down. And now we're just matching this to the answer key. Okay, so we have 0, 6. So this one's out, and this one's out because it's 0, 4, 0, 8. We need a 6. So only 1 and 4 are so far good. 2, 10, and 2, 2. So this is it. See, like 2, it should be y equals 2, and this is like 2, 10. This is the part that's no good. All right, you could even verify the others. 4, negative 2. See, like this one, like this checks out, and then 6, negative 6. So this one here is, all calculator work. If you cheat in life, you will never get ahead as much as I hate it. Yeah, I mean, look, to say like people who cheat never make it is like just not true. There are people who don't play by the rules that, get far. But it's like way less stressful if you're going to break all the rules, Like if you just do things the right way and learn it like the right way, then you're just going to be good at math. And when you have to learn the next math, it's not like, oh no, I got to cheat again. It's like, just, you might as well learn it yourself. All right, cool. That's the end of that one. So f of n equals this. Which statement is true? All right, I'm going to do the exact same thing here. So this is just more calculator stuff. A nice little trick. I don't know. I mean, is it too early to show you this trick? It might be. Yeah, you know what? I'll keep it simple. So let's look here. So n, actually, I could show you this trick. They won't mind if we use x. So x minus 1 squared. And then plus 3x. Okay? X minus 1 squared plus 3x. I'm going to show you a trick. Second window, and you change the independent from auto to ask. And the benefit of this is now when I go to the table, see, there's nothing there. But now choice 1 is the function value at 3. Okay? So which statement is true? Not 1. Negative 2. All right, so it's going to be choice 2. F of negative 2 equals 3. It's not negative 15. And if I plug in negative 15 here, you see how I get 211. Okay, so this is a nice way to make a custom table. This comes like in handy every now and then when they give you some weird numbers, like if they were like, hey, what's going on at 3.7? Like you could type in a decimal and it'll give you decimal values, okay? And then just press delete if you don't want it. But which statement is true? F of negative 2 equals 3. So 5 should be choice 2. Okay, so 5 should be choice 2. Now, let's say you're like, oh no, my calculator's out of whack. Now, we could just always go back and press second window and go back to auto. And then when we press second graph again, see, it's back to normal. All right, or you could just reset the calculator again. Okay, moving on to choice. Question 6. So the table below shows 6 students' overall averages and their averages in math class. So let's see. Oh wait, so there's, I'm looking here. Math tends to be the class that brings people down. I know it's a hard subject. It's like usually the underdog. If a linear model is applied to these data, which statement best describes the correlation coefficient? Okay, so this one here is all calculator work. Okay, so let's see here. I gotta use the calculator yet again. So this test is like, you definitely need some calculator skills. So go to stats, go to edit, and then you just got to type this stuff in. So it's 92, okay, 98. And I'm going to show you something that's like realistic, like that could happen. 84, 80, and just make sure I don't make a typo. 75, 82. And then we've got 91. Yeah, when I do these videos, like, and I edit them, I usually go at hyper speed through this part. Like I just go on like, times 7 speed, because I think watching me just type these in is like not the most exciting video, but whatever. Got to do it. Stats. All right, so watch what happens. You go like, all right, linear regression, number 4. And then you get there and you're like, oh no, it doesn't have anything I need. And that's because you got to turn the diagnostic on. So you press second 0 to go to the catalog. You could scroll to the letter D if you want to suffer, or you could press alpha and then x negative 1 is where the letter D is. So I press alpha x negative 1. I have to press it twice for some reason. But now I transport to the letter D and I turn diagnostic on. So I press enter, enter. So now when I go to stats and calculate and I do my linear regression number 4, this time around, see, now I get an R value. Okay, so that is what I want. The correlation coefficient. It tells us basically like how close this is to a linear fit. All right, and if it's a positive correlation, that means as like one goes up, the other goes up, which makes sense. Like if your overall average is really high, like 98, like your math average has to be pretty high too. Like it's kind of hard to have a 98 overall average and like a 20 in math. So like that makes sense that R is positive. R negative would be like one goes up, the other one goes down. So the R value here is pretty close to 1. Okay, so number 6 is choice 2. Now, one thing I want to mention here is like here and here, like this is strong, but it's like strong negative. Okay, and this one is strong positive. Okay, and then here it's like basically like no correlation. All right, when you're like close to 0, it's like basically like no correlation. All right, or like it's like really weak. Okay, that's the idea. But they always, like just about always make it like strong. It's either close to 1 or negative 1. So 6 is 2. All right, number 7. So what is the solution? So now this, we could just do some algebra here. This I'll do off to the side. And let's make that neater. 2h plus 8 is greater than 3h minus 6. So for this one, notice it says h less than or greater than. So I'll move the h's to the left. So minus 3h. Okay, we do this. 3h minus 3h wipes out. 2h minus 3h. You're doing 2 minus 3 is negative 1. And then h. You don't have to write negative 1. Okay, you could just write it like this, like negative h. Whichever one makes you happier. Okay, but most people, like when they move through algebra, will write it like this. Okay, like 1 is the like one number you don't have to write. Like when I write x plus 2 equals something something, technically it's 1x, but 1 is like a number that you're allowed to keep invisible in math. Okay, so 1 is invisible. Plus 8 is greater than negative 6. I'll make that a little neater. Okay, so now from this step here, I would just subtract 8 on both sides. So you got to be also like good with integers. Okay, negative h is greater than negative 6 minus 8 is negative 14. And now this is where things get funky. All right, if you divide or multiply both sides of an inequality by a negative, the sign flips. Okay, so that's going to flip. And it's going to become negative h over negative 1 is positive h, and now less than positive 14. So 7 is choice 1. Okay, so this is one way of doing it. But remember, don't fall in the trap here. Some people might say like, oh, do I flip here because minus minus? But no, when you subtract a number on both sides, that's fine. It's only when you multiply or divide. Okay, so divide by a negative, the sign flips. Multiply by a negative, the sign flips. You know, another way of doing this, if you want to see, instead of dividing by negative 1, we could have also said like, all right, I'm going to multiply both sides by negative 1. And like that's also okay, because that would give you h is less than positive 14. Okay, so either way, you get the same exact answer. All right, cool. That's this one here finished. And if people have questions, you know, feel free to throw them in the chat. I'll do my best to follow both. Yeah, so other states have their own version of the Regents. I know Texas, their test is called the STAR exam. I forget what it stands for. I've made a few videos on their test because Texas, there's like, it's like, you know, it's a bigger state than New York. So I try to make practice test videos for like the biggest states. But not to like knock them. But I think our test is, I would say, harder because of the free response. I think the STAR exam in Texas is all multiple choice. It's like 50 multiple choice questions. Yeah, August Regents, it's debatable, but they tend to be harder. So far, I don't think this is so bad though. But it's debatable. Like you could say like this. I think so at Sakura, it's just kind of random when a Regents is hard. Like sometimes they make the June Regents like pure evil, and it just has like a really low pass rate. It's like they're making like food and they overcook it. It's like, whoops, we made this way too awful. It depends. I mean, it's hard for me to say because I'm just like, all right, do math. So yeah, it's like I said, it's kind of subjective. It depends like what you're good at. But there have been some August Regents where I was like, oof, like that's really tough. So it's tough to say. Like I don't want to be like, oh, tomorrow's gonna be rough. Like tomorrow, for all you know, it could be easy. Like for all you know, who knows? But that could be easy for people who get a 90. But if someone doesn't pass it, they're like, wow, that was the worst thing I ever saw. So I would just go by the passing rate. Sorry, I'm gonna have a seltzer in between questions. Costco seltzer, lemon, good choice. All right, before it gets warm. All right, so here, this looks like just looking at this is factor completely. And they're doing a difference of 2 squares, but it looks like they're taking out a 4 first. If you took out a 2, that I could just see like 2 is not going to work. And reason being, yeah, I mean, sometimes you could just like look at these and say like, all right, which one is it? For some reason, it's looking like 2. I didn't even do any work. But I'm like most likely. Okay. Don't use that strategy on the Regents, but it's good to kind of predict your answer before you do work. Because what I'm thinking of is a squared minus b squared is equal to a plus b times a minus b. All right. And here I would take out a 4. And now what I'm imagining in my head, and I made I don't know if I released the YouTube short on this, but in my head, I'm doing 36x squared over 4 is 9x squared. Okay, so this is 4 times, we have 9x squared minus 100 over 4 is 25. Okay, so now I have a difference of 2 perfect squares. So then the next thing I'm saying here is like, okay, what's the square root of 9x squared? And I would say 3x times 3x is 9x squared. And then 5 times 5 is 25. So then the next step here, factoring, I would take this, and I have the 4 is just going to carry. And now I use that formula. It's a plus b times a minus b. So my square root of my first term is 3x. That goes here and here. And then 5 goes after the plus and minus. So yeah, 8 is choice 2. It looks good. You could kind of rule these out. Like if you think about this, you're like, wait, 9x times 9x is 81x squared. And then I multiply by 2. So 2 times that is like definitely more than 36. So that's how I know like this is out and this is out. So process of elimination works really well. Oh, an 80 is really nice. So at Mitch, very nice on the 80. That's a solid score. So let's see. Patricia is trying to compare the average rainfall of New York to that of Arizona. Comparison between these two states for the months of July through September would be best measured in. Okay, so let's see. So looking at this, a comparison between these two states for the months of July through September. Well, if we're comparing the rainfall over the course of months, something's telling me here that we're going to be thinking per month. All right, that's just my first instinct. So 9, I'm like, all right, it's per month, not per hour. Because, rain per hour just seems like kind of excessive. It's not going to be raining all the time. And I don't know if you've ever been to Arizona or if you know anything about Arizona. Right now, they're having like record heat wave. It doesn't rain a whole lot in Arizona. So that's how I know, like, all right. And we're talking about July through September. So we're thinking like months. So that's how I know, like, it's going to be the answer choice with a month. But now think about it logically. How much rainfall are you going to have? Are you going to have like feet of rain is like pretty like catastrophic. Okay. Like that's just terrifying. Like if you have like actual like feet of rain. So inches per month is like the most reasonable. So 9 is like one of those questions where it's kind of like, it's a hard question in a sense that, I mean, I don't want to say it's common sense, but like if you never really think about rainfall and you don't like watch the weather like channel enough or look at your phone for the weather app, it's like kind of a weird question. But I don't know, me just being like older, it's like, oh yeah, like I know if there was ever like a foot of rain, That's like a natural disaster. All right, like that'll like take your car away. Okay, so moving on here. So which function defines the sequence here? So this is an arithmetic sequence. See how it's going -4, -4, -4. So just looking at that, I know, I think of this as when it's an arithmetic. So an arithmetic sequence is basically the same thing as like linear. So notice these are all linear functions. And the common difference here is -4. So this tells me here, it's like, oh, that's kind of like your slope. So then I think y equals mx plus b. And this is one of those fast questions also where I'm like, ooh, my slope, my m value is -4. Something like y equals -4x and then blah, blah, blah. And the only one that has that is choice 1. Okay, but if you want to be safe here, okay, let's see here. They're saying f of 6 is negative. They're also this detail. Like, I don't want to get lazy and like not think about this, but to be safe, all right, you really want to be safe on this Regents. You don't want to like rush, like you don't want to go super slow, but you don't want to rush through, all right? You don't get a prize for being the first one done. Some people like love being the first one done, but you don't get a prize. So here, let's see. I'll show you how to do this the long way, and then the calculator is like pretty reliable. So here, all right, the first term of the sequence is -6. The sixth term is -26. Okay, so I'll just take a screenshot of this. Just to show you like how I definitely feel good about choice 1. Because once again, I think back to like when I'm teaching in a classroom, students call me over all the time. Be like, oh, could you check if I'm right? And I'm like, well, I could check it or you could check it. Like use a calculator to check your answer. So when we write this in, -4x minus 2, see our first term is -6. If we follow this pattern, we'd have like -22, and then we'd have -26. And this is like our first term, second term, third term, fourth term, fifth, and our sixth term. Okay, so that's how it matches up here. If you want to use the formula a sub n equals the first term plus n minus 1 times the common difference, you could use this formula and say, okay, a sub n equals -6 plus n minus 1 times the common difference is -4. And I'll just put the -4 here like this. And then if you distributed, you see you'd have -6 plus, and then we have -4n, and then we get plus 4 here. -4, like we distribute. Okay, so this is the longer way of doing it. It's more technical. And then you have -6 plus 4 is -2. So this is -4n minus 2. All right, but f of x would be -4x minus 2. So this is the long way. Okay, so this is the long way. But the calculator is like pretty safe here. All right, it's pretty reliable. Oh, so Fortnite, Sweaty Kid, I appreciate, I have it in the back of my mind. The reason I didn't do it yet is because it's August Regents season. So I want to make sure that I, live stream for these Regents. I'm going to do geometry in the morning. But when that's all done, I'm going to do that before the school year starts. Okay? I'm going to make it, like a personal mission to do that. I have one other live stream planned. I'll let you all know ahead of time. I don't know if this would be well received, but people in the chat can let me know. I was planning on doing the, I was going to solve 100 linear equations, like ranging from like really easy to like insanely difficult. I don't know if that would be well received, but people let me know in the chat. Do you think that would be like a good live stream, like right as the school year starts? I'll solve 100 linear equations, but I will share the document also. So if people want to like join me and suffer, I'm doing this more like so that like when my actual students like in the classroom, even though I consider you all my students too, but like my students, Mr. Cellini, thank you for swinging by. Yeah, so I got to give a shout out to Mr. Cellini as well. If anyone needs help with any of their social studies Regents, Mr. Cellini just passed 1,000 subscribers, but I checked out his channel earlier today. Mr. Cellini, I am subscribed to you, so I'll move you closer to 2,000 now. But I really like the videos you've put together, and yeah, I wish you the best of luck on YouTube. Thank you for swinging by the live stream, but got to give credit where it's due. I do enjoy what I saw so far. So keep up the awesome work. I got to down the line start doing like more collaborations with people. It's just there's so much to keep track of on YouTube, but I hope you're enjoying the ride on YouTube. It's definitely, it's a fun journey for sure to be on. So let's see here. So which function has the greatest y-intercept? So let me just, let me see. I kind of lost my spot here. I want to make sure I'm monitoring the chat as well. So I just got to reconfigure because I have two monitors, but it's, sometimes like the windows get a little bit out of whack. I want to make sure I got everything, where it needs to be. All right, this seems to be like the perfect fit. All right, so I'm going to stick with this just so I can see the chat. The live stream will last as soon as this is done. Oh, so I saw someone, I wasn't planning on doing Algebra 2 today. I just kind of ran out of time. I'm going to do geometry in the morning. What I could do though, because the Algebra 2 Regents is later in the day, maybe I could just go like nuts streaming in the morning. I just have to drop my kid off by 9 o'clock somewhere, and then I have the whole place to myself. So, I mean, I guess theoretically I could start at 9:30 and just do like a quick run through of some Algebra 2 stuff. But I was planning on doing like a full geometry test as well. So, yeah, that's for tomorrow. All right, so let's see. F of x, y-intercept. Just think of this formula, y equals mx plus b. All right, so that's your y-intercept. So this one here, you see how it's like 3x plus 0? So this is like not really a powerful one. I can see this one's already out because the y-intercept here, see, it's 1, 2, 3, 4, 5. 5 beats 0. So the line that has a slope of this and passes through. All right, so now we got to write the equation of a line. There's a lazy way to do this, and then there's like, the more technical way. So I guess you could just use this formula of y equals mx plus b and plug right in. This is your m value, and this is your xy. So you'd have negative 4 equals 2 times x plus b. And now you have negative 4 equals 2 plus b. And then subtract 2 on both sides. So this one looks like the y-intercept is negative 6, which is pretty weak. All right, so that one's out. So now it's between 2 and 4. So now for this one, you want to take choice 2 and you want to solve for y. All right, so I'll do that over here. So you got 2x plus 3y equals 12. So we got to do 2 steps of algebra. You're going to do minus 2x on both sides. So the goal, why am I doing this, is to get y by itself. Okay, so we subtract, and now we've got 3y equals negative 2x plus 12. Now, this is something students struggle with, but just be mindful. When you want to solve for y, we have to divide by divide by 3 because there's a times 3 in front. So just divide everything. Oh, Janet, thank you for the $10 and the awesome emoji. Is that a fox or a dog? That's hard to tell, but it's very nice. Thank you so much. All right, so divide everything by 3. Okay, so divide everything by 3. Each individual term. So you have y equals negative 2/3 x, and then plus 4. Wow, so this one has a y-intercept, a b value of 4. So it almost beats this, but not quite. All right, so choice 4 is our answer. This is a nice question because you have to know linear equations in many different forms. Okay, so just be mindful of that. All right, so what is the product of this and this? All right, is there a lazy way? They all have, yeah, they all, all right, so people might just say, all right, this times this is 8x to the third. Oh no, and then this times this is 18. Like, oh no, like which one is it? So for this one here, we'll just do this the long way. All right, we'll actually multiply this out. So I'm trying to think if there's a nice way of doing this. I guess there's not. Definitely going to fail tomorrow. Oh no, don't know anything. Hang on, please just go to battle as confident as you can. If you show up to battle like just saying, oh, I'm totally going to lose, then, it might not end well. But just go in there like and say, all right, I'm going to spend 3 hours putting as much math as I can down on paper. I promise you, like, unless the teacher grading your test is like Darth Vader or someone evil, most teachers like want to see you all pass. Like when I'm grading Regents, I'm like, all right, like I'm not going to give you points if like you draw a giraffe, but like I'm going to really try to help you like on your way. Like if you put something down, like they're going to look carefully. All right. But yeah, believe in yourself. All right. I really like this chat, by the way. You all have been so nice. I put like be respectful to everyone. Like this so far has been like such a nice chat. So thank you all for being nice people. 4x squared times 2x is 8x to the third. And then we do 4x squared times 3. So you're doing 4 times 3 is 12. And then the x squared just tags along for the ride. And now, next, we're going to distribute this. We have to distribute the negative 5x. So we have negative 5x times 2x is minus 10x squared. And then we have negative 5x times 3 is minus 15x. All right, and then last, what we have, I'll do this in pink. We're distributing a 6. We have 6 times 2x is 12x. And then 6 times 3 is 18. I'm just going to make sure that I'm not running off the page here. Let me just see. How is this looking on? All right, I just made it. Okay, because I know I had to like crop this around a bit. So just making sure that we're good. Okay, so now combine like terms. So we're going to have 8x to the third, but then we have 12x squared minus 10x squared is plus 2x squared. So that means these are out because they have minus 2x squared. And then we got minus 15x plus 12x is minus 3x. Okay, when you combine these, you get minus 3x. So it's looking like choice 3 and then plus 18. Now, if I had a lot of time, 12 is choice 3. I'm just going to trust that it is. But what you could do is you could type this in the calculator. You know, maybe I'll just show it now. So for the people that are like really nervous, like, oh no, I don't, like, you know, if you're like, I'm just on the cusp, I don't know if I'm going to pass or not. This, I don't say do this as like your go-to. All right, you don't want to just use calculator tricks because like, yes, you may just pass the algebra regents using tricks, but then I promise you when you get to geometry or algebra 2, it's going to be a really rough ride if you can't do the algebra by hand. So there's the product of those two. And if I look at the correct answer choice, but this is a nice way just to check your answer. You're like, all right, I think it's choice 3. And you do this, 2x squared. So yeah, I'm sorry, I got to write plus. So that's, I will never get those seconds back in life. 2x squared. And then minus 3x. And then plus 18. Okay, and if I graph both of them, see how they overlap? Okay, and if I press second graph, see how my y values all match? So like that's how I know our answer is like 100% good. So checking your answer is a nice skill to have. Okay, the height of a rocket at selected times is shown in the table below. Based on these data, which statement is not? Okay, so watch out for that word because you're most likely going to get something that is valid. The rocket was launched from a height of 180 feet. Okay, so when you want to find out where it was launched from, like just imagine this, like there's the rocket, like going up and then down. This is where it's launched from. So like choice 1 is corresponding to this, which is the time here. Like, so the time, did they give us the function name? I guess not. They just did it like, you know, so like, you know, so I'll even put XY, something we're familiar with. So the rocket was launched from a height of this is basically saying like, what is your Y value when X equals 0? Okay, because it's launched at time 0. So you could see here like, oh, my Y value is 180 when X is 0. So like this is a valid conclusion. So 13, like 1 is no good. The maximum height of the rocket occurred 3 seconds after launch. Yes, this is looking good because you can see here, this is the vertex. Okay, this is the vertex. See, it's the turning point. Okay, because you see like the values start to match before and after. It's like 308, 308, 260, 260. So this is occurring here at 3. Okay, so that is a valid conclusion. The rocket was in the air approximately 6 seconds before hitting the ground. Okay, that's not true. The reason being is that it hits the ground. This means y is equal to 0. But notice the y value doesn't equal 0. See, this is not 0. And how much time went by? This is, 7 seconds. So 7 seconds later, the rocket is still in the air. So this one's looking like the answer choice. Okay, if we wanted to solve for when it's equal to 0, I mean, that's a separate question. I could show that, but it's not really necessary. The rocket was above 300 feet for approximately 2 seconds. Yeah, that's a reasonable statement here because you see here, like at 2 and at 4, we're at like 308. Okay, and you see like from 2 to 4, that's like 2 seconds. See, like that's a 2 second interval. So 2 seconds goes by, but you're like above 308 for those 2 seconds. So sure, it's above about 300 for approximately 2 seconds. That's a reasonable conclusion. So that's why it's choice 3. Okay. So So let's see. Focus on the questions you know how to answer. Yes. Yeah, look, there's always going to be questions that are just really hard. There's not a lot of kids who get 100. So there's supposed to be questions that are just going to like ruin everybody's day. When you see those questions, like just be like, oh, hi, how you doing? And then you move on. And you come back to them at the end when you have time. All right. Don't let them like crush your spirits. All right. Just do your best to, answer what you can. All righty. So parking garage. Let's see. Charges a base rate of $3.50 for up to 2 hours and an hourly rate for each additional hour. Okay, so a base rate of $3.50 for up to 2 hours and then an hourly rate for each additional hour. The sign below gives the prices for up to 5 hours of parking. Okay, which linear equation can be used to find X, the additional hourly parking rate? So this here is the fixed amount. Now this is a very trappy question. So I guess what I would do here is put this in the calculator. The calculator might be able to do this like really nicely. Let's see. But it's worth a shot. It's like, it can't hurt to like type this in. So let's see, stats, edit, and 2 hours. So I'll start deleting this stuff out. I'll show you how to do it the long way also. So 2, 3, 4, 5. And just know you could always check your answer. Before you're saying like, this is definitely my answer, you could always check. So $3.50, $9, $14.50, and then 20. Okay, stats, calculate. Whoops. Stats, calculate a linear regression. Do they have one in standard form? Because all the answers are in standard form. I don't think they do. Yeah. All right, so we got to just do this way. Calculate, and then here's all the stuff you need. So let me screenshot this. And let me see if the numbers start to match. Because if the numbers match, then like I'm feeling good. If they don't match, I'm like, oh no. So let's see here. Oh, wait a minute. Which linear equation can be used to find X? All right. I'm sorry. That was a waste of time. That we'll never get back. But this is modeling my thinking out loud. So what you want to see here is like the 350 is like the base rate. So this is like in a way, like our constant. Okay. And then the hourly rate after that, it's looking like, I'm just going to do this in my head, 550. Yeah, I'm thinking 550. Okay. Because you see from here to here, it's like you're going up 550. And then from here to here, you're going up 550. And then from here to here, you're going up 550. So you're starting out at 350. And then let's see, you're going up some amount. Like let's pretend you don't know it's 550. Spoiler alert. So you don't know it's 550. You're saying, all right, I'm going up by X. But this is like the start. Okay? This is like your constant. And then you're going up X. So it's like, all right, 350 plus X is equal to $9, like this. And you're like, all right, that's not it. So like that's not the answer. But 350 plus 2X, like you see if I jump X twice, it brings me to 1450. So that is already looking good like choice 3. So let's just see. 14 is choice 3. Okay. So yeah, just so we're clear on what's going on here, it's like they're giving you a base rate is like, this is another way of saying it's fixed. Like that's just how much you're paying for up to 2 hours. You're paying $3.50 no matter what. But then for each additional hour, they're charging you some value X. And you could even see here, I kind of just did this in my head to see it's going up by 550. But if you did, 350 plus 550, then see it gives you 9. Gives you the next one. If I add another 550, I'll put that over here, you're going to get 1450. And then if you add another 550, it gives you $20. Okay, so now it's just going up by the same amount each time. All right, but the reason why this one's no good, let's see, 2X. Oh, because this one is saying like the fixed like is $9, which is not the case. Okay, that's not true. So that's why this one's out. The fixed is not $9. So every one of them what they got wrong was the fixed amount. 350 was the fixed amount. So like that's how the others get eliminated. Okay. Yeah. I started to make it more complicated. I think they were saying, oh, write the equation of a line that gets all of this. But then you'd have to have like a special domain. It would be like x has to be like greater than 2. Like you could kind of write it as a piecewise function. Like as a piecewise function, if we really want to like, go with this here, we say like, all right, f of x equals, this is like this is just extra. Okay. You don't need this. So don't let this scare you. Like, yeah, don't be scared of this. It's like, all right, 350 when x is like between 0 and 2. But then when x is greater than 2 is when you're using like y equals 5.5 times x and then minus 7.5. It should work. Let me just see. 11 minus, yeah, that works. 3, but it's like x is an integer also. If I plugged in 3, let me just double. Now I got to check it because it's going to bother me. I don't want to say like, yeah, that's totally it. And then like it's not. But that's like kind of like where my head was going, but that was like too complicated. Like the question didn't ask us to do all that. But if I did 5.5, I'll show you like where my head was. Because you might be like, why on earth did you do all that? Yeah, see, it gives you $9. It gives you the next one here at 3 hours. So I was like trying to write a function for it, but you didn't have to do that. Okay. That's why like you should really read the question and look at the answers before you start doing work. So you know like what form your answer has to be in. Because at the end of the day, like when I'm tired, I'm just like, all right, I just start doing math and I'm like, wait, that's not what they want. And then I change direction. So which function has a constant rate of change equal to -3? So constant rate of change means linear. Okay, when your rate of change is the same each time, it means linear. So we got to be mindful of that. Okay, equal to -3. Sadly, it's not this one. Because you see this one, we're going, rate of change is slope, and slope is rise over run. This is the nicest way to find it, rise over run. When you have a graph, okay? So for graphs, rise over run. So now we count. We're going down 1, 2, 3, 4. So we're going down 4 and over 1, 2. So this has a slope of -2, not -3. So sadly, this one's out. 4 is looking good. Okay, 4, you should be thinking of this equation, y equals mx plus b. So just divide everything by 2. And now you got y equals -3x plus 5. So your slope, m, is equal to -3. So the rate of change here is -3. And this is a linear function. So 15 is choice 4. Why not this? Well, let's see. Up 3, up 3, up 3. This has a slope of +3. Whoops, not plus minus. Has a slope of +3. Because you see, it's like, it's just going up 3 each time. Like +3, +3, +3. Okay, and this is going up +1. So the rise over run is like up 3 over 1. Okay, so if it said which one has a rate of change equal to +3, constant rate of change, then 1 would be it. But that's not the case. And then this one, down 3. Yeah, see, it's like going like, it's going down 3. And then 2 to -5 is going down 7. And then it's going like up 9. So this one's like just kind of silly. So not this. Don't write tips on your arms. It's a bad idea. Yeah, because if they catch you, it's like, yeah, just, it's cheating to write anything on. If you write like, you're awesome on your arm, like that's okay. I'm sure, don't risk it, but yeah, I would just say like, you're so smart, you're gonna pass this thing. Like that's okay. Like if you want to give yourself like words of encouragement, but I would just show the proctor ahead of time, like, hey, but I don't know, maybe just say that to yourself instead. Cause like, it just makes you look suspicious. If you have writing on, they're gonna be like, wait a minute, what's on your arm? So, oh no, I just write words of encouragement. Like, they might, depends who your proctor is. Like if they have a sense of humor, like I would just laugh it off and be like, haha, you got me. Like, but others might get really like, like, oh, why are you making me work so hard? So Kendall bought X boxes of cookies to bring to a party. Each box has 12 cookies. She decides to keep 2 boxes for herself. She brings 60 cookies to the party. Which equation can be used to find? Ooh, all right, this is a nice one. So this one, like, reread it a few times. Bought X boxes of cookies to bring to a party. Each box contains 12. So I'm like, what I'm thinking about when I read that is that there are 12x, like this is the total cookies. Okay? Total cookies is 12x. However, she decides to keep 2 boxes for herself. This is what you want to reread a few times to think about how do you include that in the situation. So keeps 2 boxes. Remember, x is the number of boxes. So if she keeps 2 boxes for herself, she brings the rest to the party. Okay, she bought x boxes of cookies to bring to a party, but each box, she decides to keep 2 boxes for herself. So that's going to be 12 times x minus 2 is equal to 60. That's where my head is going. And I would just double check this because I'm thinking like, all right, like what's the idea? I'm thinking she bought 7 boxes total because 12 times 5 would give you 60. So she bought 7 total, which means she's bringing 5 to the party. But which equation could be used to find the number of boxes that Kendall bought? So here, look, you could distribute. And looking at this, yeah, this one, you're not actually solving for x. They're just like having you start it. So 12 times x is 12x. 12 times minus 2 is minus 24. And that's equal to 60. So 16 should be choice 3. Okay. So remember, x boxes of cookies, but she decides to keep 2 for herself. Like that's why this. Okay. So this tells you to do this. All right. If she brought everything to the party, then it would be 12x equals 60. All right. And this one here, like you're not subtracting 2 from the total cookies. That would be if she decides to keep 2 cookies for herself. All right. So choice 2 would be good if she kept 2 cookies for herself. Then 2 is good. But she kept 2 boxes. So that's why the minus 2 is going in parentheses with the x. All right. That's a hard question, though. Like this one, like just read. All right. And like, you know, I know this is math, but I would read more books in your downtime. I know like we live in the era of like phones and stuff, but reading a book, I started doing that this summer. Actually, in like the last year, I've been reading a lot of books. And I like to go to the library to get like actual books because like taking a break from the screen is like really nice. And it just makes your like, you know, patience and like math maturity go up. Because sometimes in math, like you just have to reread it a few times and really think about what it's asking. Like don't just like jump into the question as fast as possible. You know, like it's something to think about. The table below shows the temperature T of M of a cup of hot chocolate that is allowed to chill over several minutes. All right, this would be good for January Regents, not August Regents. I mean, I guess I would have hot chocolate in the summer, but I feel like this would be a better question for January, just a thought. All right, what I'm noticing here, though, which thankfully, the temperature is going down. Like these choices here are out because this will, you know, this will burn your mouth. I almost wrote burn your math because we're doing a math test. This will burn your mouth like terribly. All right, so oh no. Yeah, just imagine if you want to like, I don't know if you find humor in that kind of stuff, but let's take a look. I just know looking at those, because that's exponential growth. If the temperature of the hot chocolate is 150 degrees Fahrenheit when you like, when it starts to cool, but you had 1.15 to any power, really, this is kind of terrifying here. That means like, all right, I'm gonna let it cool. Like 10 minutes later, is this in minutes? 10 minutes later, your hot chocolate's gonna be 606 degrees. Like you're gonna have to go to like the hospital. You're gonna go to ICU. All right, so not those. It's gonna be one of the others. So here, I'm seeing it's choice 1 because if I plugged in 0, 0.85 to the 0 is 1 times 150 is 150. But if I had to, like I could just kind of go trial and error here. So it's 0.85 to the x power. Yeah, let's see. So we go here and you see like there it is. 150 and then 108. And then at 4, it goes down to 78. They're rounding to the nearest like, you know, degree. And then 56. Although this one kind of rounds closer to 57, but whatever. It's close enough. Or we could write a letter to New York State about that. Like, you should have said 57, but whatever. So this one here is looking like 17, choice 1. All right, so just plug them into the calculator and see which one matches. Okay, or how about this? Even better. If you don't want to plug in stats edit, you could just run an exponential regression for this. Okay, and that'll give you the formula all at once. 0, 2, 4, 6, 8. And then you go over to this column and you got 150. You got 108, 78, 56, and 41. And I'm missing something. Oh, I forgot to write 4. But I see it wasn't even, so I knew something was off. All right, now we're good. Okay, so stats, calculate, and you're looking for the exponential regression because this is an exponential equation. And this one, yeah, see, it gives you the formula directly. So this is good if you're in like the part 2s, like part 2, 3, 4. More likely part 2 and 3. Part 4 is usually not one of these questions. Actually, no, they could ask you to like interpret it and stuff. So maybe they could get 6 points out of this, but not commonly. So you see here, it's like, all right, y equals a is just about 150. And then it's b is the base of the exponent is about 0.85. And then to the power x. So it's like same thing. Okay, except m instead of x. All right. As x increases beyond 25, which function will have the largest value? This one. I'm looking at 18. It's like, all right, choice 1. Just know here that there's, power versus exponential. Exponential is always stronger, okay? This is always stronger. As long as it's like y equals a to the x and your base is greater than 1. Okay, so you might be saying like, wait a minute, 1.5, like that's a small number. Like I would rather x to the third. Like if I plugged in 10, this seems strong. But just know power functions are like x to the first. Something with like x to the second, x to the third, x to the fourth, even like x to the 100. Like if I had a choice, like which one would I want to be like my bank account, like this or this, I still want this. Okay, exponential functions, when your variable is in the exponent spot and your base is a number, exponential functions are stronger than power functions. So I just know it's choice 1. Okay, and let me look. Yeah, 18 is choice 1. Okay, you could make a table for this and spend a lot of time, but once again, but don't like quote me on, like don't say, all right, let me see. It's like, choice 5 and say, w of x is equal to 0.5 to the x and say like, oh, exponential always wins. Like, no, this is exponential decay. Okay, if your base is like let's say you have a situation like this, y equals a to the x. If your base a is between 0 and 1, then this shrinks. Okay, so then this graph is going to shrink. Once again, it's going to look something like this. Okay, but a greater than 1 is exponential growth. So just, yeah. Cool. This one, we could use a calculator to do this. Because in the free response, we're going to have to do one like this anyway, but let me think. Yeah, you know what? Either way, we're going to have to do -8 on both sides. So do that first. And that's going to give you 3x squared plus 10x minus 8 is equal to 0. So I'll show you some calculator stuff too. Because once again, in the free response, I believe they have like a quadratic where you have to do it algebraically. So I might as well show you like a calculator technique. So you write 3x squared plus 10x. And then you got your minus 8. And now I go to the graph and see here I've got 2 roots. So here it looks like -1, 2, 3, 4. -4 is, -4 only shows up in choice 1. So this is looking good. But let's say it wasn't obvious. Like, wait, I want to be sure that this is 2/3. You press second trace, and 0 is the same thing as like finding the root. Okay? So enter, go after, hit enter a second time, hit enter a third time. And 0.6 repeating. Like if I go here, second mode, and I press second minus for the answer, and I do math answer, enter. See, it's 2/3. Okay, I'll do that one more time. Second, trace number 5. I want to trace the intersection. I hit enter before, I scroll to the right, I hit enter after, and I hit enter a third time. Okay, and it's, oh, I'm sorry. Second, trace 0. I'm tracing the 0. I hit enter before, enter after, and enter a third time. All right, another way of doing this, I saw another teacher do this, one of my coworkers. They write in y equals 0 here, and then what they do is they press second trace number 5 for intersection. And then you could see when does the blue graph intersect 0, and you just press enter 3 times. See, and it gives you this. Okay, second trace 5. I could go on the other part here. Let's say I'm not confident that that's -4. I press enter 3 times in this neighborhood, and I get -4, 0. Okay, so either way, choice 1 is our answer. But you still need to do a little bit of algebra. You got to move the 8 over to the other side. Okay, so that's important. I'm going to do one tomorrow for geometry, yes, at 11 a.m. So at Nikolai, geometry is tomorrow at 11 a.m. while everyone's taking algebra. So I'm mainly doing those because, what's it called? Those are the most popular regions. So I'm not going to have time to do like a full algebra 2. I could probably answer a few questions tomorrow, but cool. An online company lets you download songs for 99 cents each after you paid a $5 membership fee. Which domain would be most appropriate to calculate the cost to download songs? All right, let's see here. Lets you download songs for 99 cents each after you paid. So it's like $5 plus 0.99x. So lets you download songs for this after you paid. Which domain would be most appropriate to calculate the cost to download songs? So the cost to download songs is this one here. It's not integers though. I want to say here it's rational numbers because of the 99 cents. Okay, whole numbers, integers less than or equal to 0, that would be like they pay you. So 3 is out. All right, let me just see here though. I got to think about this carefully. So for 20, which domain would be most appropriate to calculate the cost to download songs? Let me just see here. I want to think about this. See, this is a question I would like reread a few times and come back to, because the fact that they're saying domain. Let me see. Domain makes me think X. So what threw me off was like this is the cost, like total cost, because it's $5 plus 99 cents, and this is like the number of songs. So my instinct here is to say, like, my first instinct is like, wait a minute, which domain would be most appropriate to calculate the cost to download songs? What it sounded like for a moment was like which set of numbers would be best to talk about the cost, but that's not what it's asking. Which domain would be most appropriate to calculate the cost to download songs? So the domain is referring to X. So X like is your domain, and your range is Y. So I always read these questions as carefully as possible. So domain X, number of songs is whole numbers. Whole numbers less than or equal to 1 doesn't make sense because you're not going to download negative songs, okay? Like negatives don't make sense here. Integers less than or equal to 0, negatives don't make sense. So that's why like I was stuck between like 1 and 2, but after rereading it again, the number of songs, you're only going to download a whole song. Like you're not going to download half of a song. So I'm looking at this one and saying 2 now. Once again, if they said which range would be most appropriate, then I would say rational numbers, because if you bought one song, like, you know, when X is equal to 1, you know, you buy one song and you're going to pay $5.99. Okay, 2 songs, then you're going to be, oh, I got to do a little math here. Let's see, plus $1 minus 1, so it'd be like $6.98. okay, and so on like this. So then, like you see, your y values are not whole numbers, like they're decimal values. So these are rational numbers. Okay, so these are rational. So once again, no matter what level of the game you're at, take your time doing these. Okay. Yeah, someone look up let me just double check. I think 20 is 2 though. I have the document off to the side. Let me just click on it and see. But 20 should be 2. Let me just see. I'll scroll over to it. 20. Yes, 20 is 2. Okay. Cool. Yeah, I didn't have time to like really do these ahead of time, so I'm just kind of like sort of winging these. I just came back from vacation, so I'm pretty tired right now, but I'm gonna power through this for my August people. All right, written in vertex form. So we're in the multiple choice. So one option here is to expand this and see which one matches this. So like my lazy way of doing this, and then I'll show you the painful way, is looking at this and saying, all right, I need a 3x squared to start. So these are in the mix. This is out, okay, because 3x times 3x is 9x squared. So that's why 1 is out. And then I'm looking at, like, this is our, like, last term. So let me change colors here. Like, our last term, or our constant, is 11. So just seeing this, I'm like, all right, 2 is out. Yeah, 2 is out because it's 6 times 6 is 36 times 3 minus 25. That's 108 minus 25. So this is just like me doing mental math and seeing like that's definitely bigger than 11, whatever that is. So like that's why this one's out. And then this one, I have 4 times 12 minus 1 is 11. Like this one, I'm like, ooh, I think this one's good. So you see, like, I'm looking at that one saying, all right, 2 times 2, like, so 3 times 2 squared, and then minus 1. So I know the last term here is going to be 11. But if I did this one, I'd have 3 times 2 squared plus 7. That's going to give me 12 plus 7 is 19, not 11. So, like, let me check. 21, I have that document open now. 3. Yeah, 21 is 3. But now I'll show you how to do this, like, the technical way. Okay, so that's, like, just using process of elimination and plugging in numbers. All right, but if we want to do this like the technical way, then vertex form is y equals a times x minus h squared plus k, where your vertex is hk. Okay, so here your a value is 3. So that's like, you know, when you have ax squared plus bx plus c, the a value is like the same. But now to find your h value, remember the formula, your h value of your vertex is negative b over 2a. So h equals, I would have negative 12 over 2 times a is 3. So negative 12 divided by 6 is negative 2. So then if I plug into the formula, so far I have y equals 3 times x minus h is negative 2. And then plus k. K I get by plugging into this. So here, if I plug in k, let me just find a spot. I'll do this over here. I would have, you know, f of negative 2. And I could use a calculator for this, but whatever. I'm like already on this. So I plug in negative 2. And this is going to give me 4 times 3 is, that's going to be negative 2 squared is 4 times 3 is 12 minus 24 plus 11. So that's negative 12 plus 11, which is negative 1. Okay, so this represents my k value. My vertex is negative 2, negative 1, so my hk is negative 2, negative 1. So I have plus k is negative 1 at the end. So this is a more technical way of doing it, what I'm doing over here. So I have 3 times x, and it's squared, of course. I forgot to write the square, but whatever. So x plus 2 squared, and then minus 1. So that's how it matches 3. If you're doing this the technical way. All right, but once again, like you could do this any way you want. All right, 22. Moving on here to this system. So let me check the chat because I kind of bounced around a bit, like pulling up the answer key. Because I want to have the answer key like on standby just so I could make sure I'm good. Oh no, don't fail again. Oh, but you're laughing, so maybe it's like half funny, half serious. Um, oh, you think the Regents? I think the Regents. I mean, I don't want to say like it's okay, and then people don't do well. The reason why geometry is harder than algebra is that I think I have to check the curve, but I think you like need to know a little more to do well, because you need one math Regents to graduate, so they usually make the first one like the most passable. Geometry is like a harder test, but if you do the work, like it's doable. Like I've worked with a lot of amazing students over the years, and I've seen kids like who really, really struggled, but they worked so hard and they got that passing grade in geometry. So like, like if you don't get it on your first try or second try, like I know it's discouraging, but like you can eventually learn it. Like there's really a lot to be said about you working hard. I always say it's like one of the best lessons you can learn in life is like how to like struggle and get through something. So this one, which system of equations does not have the same solution? So here, we could use the calculator for this, but I guess why not practice doing this the long way? I forget if the free response has one when we're doing this the long way. So why not? I'll show the calculator trick, because in the free response we have to do a system by hand. So that's like it's just going to be pain and suffering. So let me see. I want to say program. No, not program. Apps. Yes. Apps. And then number 9, polynomial simultaneous. And simultaneous equation solver, number 2. 2 equations and 2 unknown variables. And I'm going to press the graph button to go next. And now I write the first equation as 1x. Remember, the 1 is invisible. Plus, I hit enter and I press 2 to write my coefficient for y equals 5. And now my next one is 2x plus, and then 1y equals 4. And then I just press graph to solve it, and my solution is 1, 2. Okay, so the solution here is 1, 2. Now, just to make sure I didn't make a typo, like you could do a quick mental check. If you did 1 plus, 2 times 2, 1 plus 4 is 5. And if I do 2 times 1 is 2, plus 2 is 4, like, yay, it checks out. So then I'm just plugging this into the other answer choices. Like, choice 1, I could do the calculator trick the whole way. But 3 times 1 plus 6 times 2, that's going to give you 3 plus 12 is 15. So like, yay, it works. We want to know which one does not have the same solution. So not which one does. So then 2 times 1 plus 2 is 4. Like this one, it works. So we want the one that does not. So we have to do this the whole way through. Let's see. 4 plus 16 is 20. So this one works. 2 times 1 is 2. Plus 2 is 4. This one works. Like, all right. They're probably going to make it the last one. That's like their idea of a joke. 2 times 1. I'm sorry. 1. X is 1 plus 2 times 2 is 5. So like that one works. 6 plus 6 is 12. Okay. So if you do 6 times 1 plus 3 times 2, that's 6 plus 6 is 12. So that works. So it has to be 4. But let's see, why does 4 fail? So we'll do this in a different color. We'll do this in purple. So 1 plus 2 times 2. Wow, they make it fail on the last equation. So I would be like really sweating here. Like, oh no, which one is it? And then this one here, 4 times 1 plus 2 times 2 equals 12. There it is. 4 plus 4 is 12. No, it isn't. 4 plus 4 is 8. So that's why this one does not have the same solution. Okay, it satisfies the first, but not the second equation. Oh, that would have been lazy. Like x plus 2y equals 5. Like that shows up in this one. So like obviously it has to be true. But then this one is no good. All right. There might have been a nicer way. I mean, I don't know. That works. We'll solve another one by hand later. All right, 23, the second to last. Let me see. Do we have more? Oh, wow, the chat is really rolling here. All right, let's see. Did I miss anything? Am I deleting the stream? No. I am not deleting these streams. You could watch it, in the morning before. Yeah, that's the thing too. If you want to go to sleep, like please go to sleep. Don't stay up late and then show up tired to your test. There will be a live stream in the morning, so if you're commuting to school, like you could watch the rest of it. If it's like easy for you to understand, like I would recommend you watch it like on double speed. Oh, we're already hour and 14 in, so let me like speed up a little bit. I'll talk a little less to the chat, but I'll check in every now and then. See you guys here in January. No, don't be silly. You could pass this. All right, so here, based on the graph, which expression is a possible factorization of p of x? So one thing to know is that roots and factors have an opposite relationship. Okay, roots and factors have an opposite relationship. Oh, I gotta spell. Okay, so here I'm looking at this and saying, all right, there's roots. The roots are where the graph crosses the x-axis at -1, 2, 3. So at x equals -3, at x equals 2, and at x equals 4. So then what I'm thinking here for p of x, when I say that the factors and roots are opposite, I just take whatever the roots are and I flip the sign. So it's x, and then for this root here, like if I color code this, like x equals -3, that would correspond to a factor of x plus 3. Okay, so instead of -3, I write x plus 3. And then for the second one, we have a root of x equals 2. So you see how it's x equals +2, I would write x minus 2 here. And then for the last one here, x equals +4. See, x equals +4, that third root, I would write the factor as x minus 4. Because if you think about it, when you're finding roots, like you set this equal to 0, you set each one equal to 0. So like x plus 3 equals 0, x minus 2 equals 0, x minus 4 equals 0. And when you solve, the sign changes. So like -3 on both sides. And x equals -3. Okay, so that's how, this is like a nice little trick to know. So x plus 3 has to be there, not x minus 3. And then it's got to be x minus 2. This has too many roots, so that's out. So 23 has to be choice 1. Okay, and it matches what we have here. Cool. All right. So next up, Milton has his money invested in a stock portfolio. The value v of x of his portfolio can be modeled with the function v of x equals 30,000. Ooh, we put 30 grand in. And 0.78x. Yeah, his investment is going down, sadly. Sorry, Milton. That's unfortunate. So this formula, this is a good formula to have. So here, if the base, notice that the base here is 0.78. That is between 0 and 1. So that's the minus situation. So looking at this, see how it's like 22% or 78%. So here, this would be an R value of 0.22. And notice I have A equals capital P is 30,000. So this is like his initial investment. He puts $30,000 in the stock market. And then it's sadly 1 minus 0.22. That means his investment shrunk by 22% per year. I mean, that's pretty bad, but that's not as awful as it could be. It's still pretty bad though. Eventually, like, I don't know, you have to have faith in it. So then this would simplify here to, you see how it would be 30,000 and you'd have 0.78 to the x. Okay, so when it's minus R, that's a decrease, not increase. So it's decreasing by 22% per year. All right, if it decreased 78% per year, that would be really depressing. That would be 30,000 and then you'd have 0.22 to the x. Okay, so then it would be this. So that's why this one's out. If it increased, that would be awesome. You know, this would be the best case scenario, but that's not, sadly. Then it would be 1 plus 0.78. So it would be 1.78 to the x. So that's why this one's out. And then this one, why is it not 4? An increase of 22% would be 30,000 times 1 plus 0.22, which is this to the x. So that's why this one's out. All right, so 24 is 2, and that is the end of the multiple choice. Awesome. All right, let me just see here. Should I? Yeah, for the people rewatching, I'll press the insert ad here at this location. So, wow, 322 views. Oh, and I should mention here, if you have not subscribed, please, if you could, consider subscribing. All right. My goal is, let's see, how many subscribers are we up to? Let me see. Oh, yeah, we're closing in. We're getting there. Yeah, if I could hit 25,000 subscribers, that would be really cool. I'm 34 away. So, yeah, anyone who is not subscribed, consider subscribing. Oh no, yeah. So if you don't understand, say exactly what. This is the formula. Okay, so this one, it's the last question. It's definitely a bit tricky because you have to like think backwards here. So one thing to be mindful of, maybe this wasn't mentioned well enough. So let me just see here, is that if your R value is 78%, 78% is the same thing as 78 out of 100. Okay, if someone gets a 78% on a test, that's 78 out of 100, and that's 0.78. Okay, just know like you could always, yeah, you could always like just, let's see, 78 out of 100. Like if you had to do this by hand, 78 out of 100. See, it's 0.78. So, and then I'm just plugging into the formula. So you're just running it through. Algebra 1, yeah, June 20. It's already posted. Thank you for, yeah, updating in the chat. So 2-point questions. Graph this function. All right, so now let's see here. So for this one, calculator for sure. So let me pull up the calculator. Geometry is going to be a little tricky tomorrow because I don't have to do construction with a compass. So I got to get that program ready. All right, it's negative. So use this. Don't use the subtraction sign. That's the first thing people do when they mess up. They use this. Use that minus, not that one. That's for subtracting. This is for negatives. And then square root is second x squared. And then x plus 3. You press graph. And you're like, all right, this is what I have. But the table is especially like what's helpful here. Notice there's an error after -3 because that's like the graph, the domain is just x is greater than -3. So let me take a screenshot of this. How many points we have? 1, 2, yeah, 4 points is plenty. All right, you don't need to have 1,000,000 points. Like, the few points we have here should totally do it. Okay, so if I was like actually writing this out on the Regents, just in case like I mess up something small, I would just pick like a few values here. I have -3, 0. Only pick whole numbers. Don't try to graph like 1.732, like -1. Like that's, you'd have to bring a magnifying glass and you'd probably still be off. Okay, so just pick the whole numbers, like 1, -2. Yeah, try not to don't get anything with decimals. And then 6, -3. And then once again, if I pull up the calculator, like look at the graphs, like what it should look like. Okay, like if this is what it should look like, that's what your picture should be. Just know like this is a common mistake. Students go, all right, I got this, and they just go like, let me see, like, all right, there's my, let me fix that. They just go like this. They go, there's my answer, and that's gonna get you nothing. Okay, that gets you no credit. You're like, wait, but it looks like my calculator. Like, no, that's not gonna get you anything. If you want credit, you have to, it has to have the exact coordinates as accurate as you can make it. So -3, -1, 2, 3, 0. So that's going to put you over here. Okay, so that's at -3, 0. And then at -2, -1, that's going to put you, so let's see, -2, -1 puts you here. Okay, and then after -2, -1, we could go to 1, -2. So 1 and then -2 is going to put us down here like this. And then 6, -3. So this is, let me make that part a little neater. So here, this is at 1. And then we said -2 we'll put over here. So at 1, -2, we're here. And then 2, 3, 4, 5, 6. And then -3 is down here. We'll put this point over here. Okay, so then we connected this one. Don't put an arrow here because this is where the graph begins. Okay. Remember, there was errors for -4, -5, and so on. So this is the beginning of the graph. So let me just draw this as neat as I can. Let me try one more time. Okay, and then there's your graph. If I look at the calculator once more, I think this is like the last reasonable point. Yeah, because you see, like, you don't get another whole number here until 13, and the graph stops at 10. So this is like more than enough. Okay, this will get you full credit. You don't have to put an arrow if you go to the end of the graph. All right, so that's another thing to be mindful of here. That, whoops, I shouldn't have stopped, but whatever. If you go like this, let me just fix that. You could go here, and you don't have to put an arrow if you go to the end of the graph. But I just personally like to put an arrow. Let me try that one more time. I had it nice before. Okay, so there's our function. All right, the table really just makes it like nice. Okay, so this one, the graph of b of x is transformed using this equation here. So we have b of x minus 2 minus 3. So my advice would be, like, if you're like, oh no, what's the answer here? Like, take something familiar. Let's say b of x. I know b of x is not x squared, but just pretend b of x is x squared. Let's say you forget the rules. Like here, I just know, like looking at this is going to go to the right 2 units and down 3. Okay, so this is just from knowing the rules, that when you have something like f of x, so I'll think about that over here. Like what I think about, if I have f of x, like if I go, let me actually do it like this. If f of x goes to like f of x minus c, like this is c units. I can't believe I spelled that wrong. C units to the right. Okay, and if it goes like f of x plus c, that's c units left. All right, and then a minus 3 will send it down if the minus 3 is outside the function, and then plus 3 would send it up. So that's how I know. Describe how the graph of b of x changes to form the graph of h of x. You could just even say here, like, to the right 2 units and then down 3 units. You don't have to say a whole lot. In this situation here, less might actually be more. You could literally just say this and get full credit. 2 units right. And, you know, or I'll even, I could put a comma here, but 3 units down. Okay, less is more. Like, that's describe. You don't have to write a full sentence. You just describe it. If you want to say h of x is b of x shifted 2 units to the right and 3 units down, like that's a nicer sentence. So yeah, like a nicer way of saying it would be to say, like, describe how the graph of b of x changed to form the graph of h of x. You could say, like, h of x is formed, like you could say h of x is formed by shifting, you know, and then you just write your sentence here, by shifting b of x 2 units to the right and 3 units down. Okay, but this here, what we have in blue, will get you 2 out of 2. Okay, that'll get you full credit. So less is more in a situation like this. But let's say you forget these rules. You're like, oh no, I forgot the rules. Just pick out a function like x squared. X squared is like a really good one to use. And then you run it through. You're like, all right, what if I replace x with x minus 2? So that would be if I did x minus 2 and then squared. You see how it sends the graph 2 units to the right, like we said. But now what happens if I also put a minus 3? It's going to send it 3 units down. So you see, 2 to the right and then down 3. So that's how I know our answer is good. You know, just pick out an easy function like x squared. All right, 27. So now let's see. So I'm also going to have the rubric next to us, so we know, like, what's the nicest way to say this. But we actually have to explain our answers. So when they say explain, we have to write a sentence. So we have a pattern here. And notice there's 2. So there's 2 squares, then there's 4, and then there's 8. So which type of model, linear or exponential, should be used? Well, what I think about with this, and then I'll write my sentence, is I'm like, okay, 2, 4, 8. This is going times 2 each time. It's doubling. Okay, if it was something else, like let's say it was this. If it was 2, 4, 6, this would be linear, because this would be plus 2 each time. So if you're adding the same thing each time, this is a constant rate of change. Okay, so constant rate of change, this would be linear. But when you're multiplying by the same number each time, that's exponential. Okay, so which type of model should be used to determine how many squares are in the nth pattern? You could say an exponential model should be used to determine how many squares are in the nth pattern because. Okay, so an exponential model should be used. Okay, so an exponential model should be used. And I'll just say because. We don't have to write like the longest sentence. It's only 2 points. Should be used because the number of squares doubles each time. The number of squares doubles. All right, that's the $1 million phrase each time. Okay, so that would tell us here. So if you wanted to add more, you can, but this is fine. If you wanted like extra, let me just put this in a different color. So like extra, which is like not needed to get full credit, but you could say, like you could also say like, oh yeah, so the rate of change is not constant, but that's really like not necessary. When you mention like that you're talking about like, oh, each term from one to the next is doubling, that tells you that it's exponential. Okay, when you're multiplying by the same thing each time, because the number of squares doubles, okay, which is like, you know, times 2 each time. This would get us full credit. All right, so 28. When multiplying polynomials for a math assignment, Pat found the product to be this. He then had to state the leading coefficient of the polynomial. Pat wrote -4. Do you agree with Pat's answer? Explain your reasoning. No, I don't agree with Pat. I see where Pat went wrong, though. Okay, let me just fix this. Pat is saying -4 because that's the first coefficient. But the leading term, what do you think leading coefficient? To avoid the bear trap, you should think standard form. Okay, and that would be writing it as like -2x to the third plus 8x squared minus 4x plus 5. Okay, you write the highest power of x first. And this, the leading coefficient would be -2. Okay, so do you agree with Pat's answer? Like, no. I would just say no first. Do you agree with Pat's answer? Answer it. No, I don't agree with him. Explain your reasoning. The product in standard form is, and then we write out what we were thinking. -2x to the third plus 8x squared minus 4x plus 5. So the leading coefficient. So the leading coefficient is -2. Okay. And if you want to say why, like you could say because that is the coefficient of the highest power of x in the product. Okay, like that's probably saying like way too much extra, but it covers it. All right, so yeah, for question 28, just gonna look at the rubric here, just seeing what's the language they use. Yeah, a complete and correct response. So this would get you there. Cool. Question 29. So now we're moving on here and just gonna have the rubric on the ready. So there's a few ways you could explain this. Is this sum rational or irrational? So this one, like they really give you like a lot of leeway here. The sum here, if you just know how to add radicals, you could say this plus this is 7 radical 2. So just looking at this, I'm saying this is irrational because we have a positive whole number, a positive integer times an irrational number. So what I'm thinking for a question like this is when you have the square root of 2, the square root of 3, not the square root of 4, square root of 5. The square root of a non-perfect square is irrational. So the fact that we have square root of 2 and 2 is not a perfect square, irrational. And we're multiplying by 7, a positive integer. So it's going to be still irrational here. All right, so that's enough to like write our sentence. You could also go full calculator on this. Okay, so let me just see here. Let me get the calculator open. If you did on the main screen here, 3 radical 2, and you exit and plus 4 radical 2. So there is the result. Okay. You could say irrational because the sum is an infinite decimal with no pattern. Okay, so that would get you full credit too. But my favorite way to say this is the sum rational or irrational. I would say the sum is let me just write it like this. The sum, and I would actually write out what we got. 4 radical 2 equals 7 radical 2 is irrational. And there's a few ways of explaining it, but I like to use the one like where it's like a little bit more based in theory. Is irrational because the product of a positive integer. And I'm saying positive integer because if I multiply by 0, 0 times square root 2 is 0. And that's a rational number. Okay, so the product of a positive integer and an irrational number so, and if I even want to specify here, let me move this over. Like the ones, but they should, like, they're not going to really like get too crazy here, but the product of a positive integer, I'll say, you know, the 7 here. So we're doing 7 times an irrational number, square root 2. So they know what we're talking about is irrational. Okay. I don't even have to include that because like I wrote it out already. So I'll even take this out of it just so it's like less, because I always like to show like the least amount you have to write. Okay. So the product of a positive integer and an irrational number is irrational. So that's enough. Okay. You could also say the sum 3 like this like equals this is irrational because it's an infinite decimal with no pattern. All right, so that's also fine. You could say this like over here. You want to see a second way to get credit? You could say is irrational. Make that a little, so irrational. Because, so I'm just going fast. This is like a second way to write this out. Is irrational because the sum is an infinite decimal without a repeating pattern. Okay, repeating pattern. Okay, so I went through that one a little bit faster. The one in red might be nicer to use. But I don't know, I just tend to use the blue one more. It's just like, it seems more like technical to me. All right, the graphs below show 2 functions, f of x and g of x. State the values of x for which f of x equals g of x. So this is, look for the points of intersection. Okay, we don't have to explain anything. Okay, no explanation required. Just what are the values of x for which these functions are equal. The points of intersection are here and here. At -1, 2, 3, and 1. So I would just say here, f of x equals g of x when x equals -3 and x equals 1. Okay, and I'll just double check the rubric here. So I have the rubric in the PDF on the side. And yeah, at 1 and -3. A student also wrote this. So you could like, don't be like, so let me just fix that, make that nicer. And that also didn't work. Let's try that one more time. Oh, not a circle. Sorry, this is like, here we go. Okay. So a student also wrote this, like f of 1 equals g of 1. And they wrote f of -3 equals g of -3. This is also like full credit. Okay, so like be careful how you write it. I'll show you one way a student lost credit. So I'll show you a -1 solution. Whoops, I don't know what's going on with this. Hang on. Oh, because I bumped into my mouse. Sorry, 3rd time's a charm. Okay, here. So this is only like plus, this is a +1 solution. A student wrote this. F of x equals g of x is 3 and 1. Oh wait, that even got, oh wow, this even, you know what, hang on, is 3 and 1. This got 1 point, but I don't know, them not saying x equals is kind of sloppy. So they're pretty, like I said, they're pretty forgiving here. But this is not full credit, so I'll cross it out. All right, find the zeros algebraically. If you do it then using something other than algebra, you get partial credit. So if you're like a calculator and you get partial credit, like, hey, go ahead and get partial credit. But here, if I'm going to do this algebraically, I want to know when is x minus 3 squared minus 49 equal to 0. There's a few ways you could do it. My favorite way is actually to use the square root property. I think it's like the slickest way, because this is in vertex form. So when I get here, I add 49 to both sides. I take the square root of both sides. But be careful. Don't say x minus 3 equals 7. X minus 3 equals plus or minus 7. Okay, because when you take the square root, just know when you take the square root of x squared, it's plus or minus x. Don't say x. So that's a common mistake. So that means x minus 3 equals plus or minus 7. So that means x minus 3 equals 7. Or you have x minus 3 equals minus 7. So you solve both, plus 3, and x equals 10. Or you have plus 3, and you got x equals negative 4. Okay? So those are your options here. This is one of your options, and I really like this option. This gets full credit. I'll show you like another way a student did this to get full credit. I'm just going to copy and paste. So I have the rubric open with sample responses on the side. But a student also did this. So if you want, you could expand it. Combine and then factor x minus 10, x plus 4, and then set the factors equal to 0. But I think here just doing the square root property is like pretty nice. It's something different. But if this is safer for you, then do that. All right? Cool. Let me just check on people in the chat. I haven't talked to the chat in a while because I'm trying to get through a bunch. Let's see. Oh, wow. We had 410 people stop by. And, oh, wow. We are at 24,974 subscribers. We are closing in on 25,000. If we could get to 25,000, that would be so cool. Little by little, we'll get there. All right, so if you haven't subscribed yet, and this is helping, consider subscribing. Alrighty, so let's see. Moving on now to question 32. I'm only going to have the rubric side by side because I think it's fun here to see like different ways of doing this. Different ways of getting full credit. But, all right. So solve for x in terms of a. So here, distribute. And let me fix this. So that's going to give you 4ax plus 4 times 3 is 12. And then we have minus 3ax. And maybe this I'll write in a different color. Okay, so this was like the stuff in red. Minus 3ax equals 25 plus 3a. So just looking at this, I see, all right, I am going to, let me fix that, combine these two. Okay, so 4ax minus 3ax. What I'm thinking in my head here, because this is where literal equations get a little bit tricky. I'm just combining the coefficients. 4a minus 3a is 1a, or just a. So I have, like, just imagine you were doing just 4x minus 3x is 1x. But if there's an a involved, like 4ax minus 3ax is 1ax, or just ax. Okay, and then plus 12 just carries down. So this is the highlighted stuff that combined. And then you've got this is equal to 25 plus 3a. And now solving for solving for x. The goal is to solve for x. I'm going to subtract 12 on both sides. And I'm going to write it next to the 25 because that will combine the 25 and minus 12. We can combine those. So I have a times x now equals 13 plus 3a. And then just divide both sides by a. And there's x in terms of a. X is equal to 13 plus 3a over a. Okay? And this will get you full credit. Cool. So these aren't going to show tomorrow. No, this isn't on tomorrow's Regents. But there'll be questions like it. I'm hoping this some of it shows up and helps you. All right, part 3. So linear regression equation for this data. All right, so linear regression equation, like now, what we're looking at here is we're just using that calculator stuff. So I'm just going to have the rubric open in a moment. Like, I'm sorry, like next to me so we could see in a moment like how we're scored. So stats, edit, and I'm going to enter this data. All right, this is going to be pretty painful. I got to just type this in. So 0.17, 0.19. We've got 0.22. And then, yeah, so this is just a lot of typing. Wait a minute. Something seems weird. The median diameters of grains of sand and the slope. Why is the x's repeating? All right, well, you know what? It's still going to work, though. I'm just going to keep continuing because I'm looking at that like, wait a minute, that's not a function if it has repeating x's and different y's. But that's not going to be an issue here because I guess they're just doing a line of best fit. Okay, so this doesn't necessarily have to be like, a set of points that like follow the conditions for a function, like the relation. But that was just something that jumped out at me. I haven't seen that, like, I don't think ever. But interesting. All right, and now got to type in the other stuff. 0.63, 0.7. All right, it's 10:15. I'm just thinking out loud. So just trying to get through this before 11 if possible. So 1.15, and then 1.5, 4.4, 7.3, and 11.3. And I did not miss anything. Cool. Stats, calculate linear regression, number 4. And keep pressing enter. And there's the stuff we need. Now this, they're probably going to ask us to round to the nearest something place, so we have to know how to round here. Yeah, to the nearest 1,000th. Okay, so now we just extract everything. I personally, it can't hurt. I would write out like, all right, A equals 17.159. Now I know I'm rounding to 1,000th is 3 places. So you see here, like we have a 9, and to the right of the 9, let me just fix this, is a 3. Okay, so the 3 tells us to round down to 17.159. Now my B value, see how it's AX plus B. For my B value, my 1,000th place is a 5, but to the right is a 9. So I'm going to round that up. All right, so this is going to round up now to, and let me just fix this. Yeah, sorry, this is like, I have it like not maximize the screen so that the calculator could go like in and out here to negative 2.476. Okay, so 4759 rounds to 476. So now here I just have to write the equation. So it's y equals, and it's ax plus b. So I have 17.159x and then minus 2.476. Okay, so this is the first part of my answer. All right, cool. So using this equation, predict the slope of the beach to the nearest 1/10 of a degree on a beach with grains of sand having a median diameter of 0.65. All right, so now this is where what you could do is you could just plug 0.65 into this formula. Or a second way of doing this, probably my favorite way of doing it. Well, I don't know if I have a favorite, but now you could just write this equation here. So you have 17. I mean, I guess you're going to have to show your work anyway, so whatever. I'll just do this on the main screen. 17.159 times x, but you see how they're telling us with grains of sand having a median diameter of. So you see like median diameter of grains of sand in millimeters. So that's the x we're plugging in for. So we're plugging in x equals 0.65. Okay, and the rest of the equation here, remember, is minus 2.476. I don't know what I just wrote. Minus 2.476. There it is. Okay, and now I'm going to copy and paste this because I will forget that. Whoops. Let me just get this. All right, now we're good. I'll just press delete on this. Or I guess I just clear that line. I mean, whatever. It's not important. Oh, wait. I forgot to actually drag the screenshot. Sorry, I got to fix fixated on like the non-important details here. Let's try that again. Here we go. Okay, so I would just show this work here. I would show y equals, and then 17.159 times x, and then minus 2.476. But the calculator does the annoying part. So y equals 8 and they said to the nearest tenth. So look, there's a 6. You look to the right is a 7. We're rounding up to 8.7. Okay, so here we have y equals 8.7. And that gets us our other 2 points here. So a complete and correct response. It's going to be 2 here and 2 here, most likely. All right, cool. So now question 34. So now we're moving on here. So let's see. I'll just have the rubric on the ready so we could talk about how this will be scored. But let's see. Sean incorrectly graphed the inequality here. Explain Sean's mistake. All right, so for this, I would solve for y. I'm thinking y equals mx plus b, except like it's an inequality, but that's the idea. Slope and y-intercept. So negative x minus 2y is greater than or equal to 8. First, I would add x, and this cancels. You have negative 2y is greater than or equal to x plus 8. Okay, so just add x to both sides first, and then divide both sides by negative 2. So y, I'm dividing by negative, flips to we have, and just know there's an invisible 1 in front. So I could think, let me write this on the side. When I see 1x over negative 2, let me write that over here. 1x over negative 2, that's the same thing as negative 1/2 x. Okay, so that like is not an obvious detail for people with algebra, but that's, you could just rewrite this as negative 1/2 x. It has the same meaning. So negative 1/2 x, and then 8 divided by negative 2 is negative 4. So notice we have a y-intercept. So our, in a sense, like our b value is negative 4. 1, 2, 3, 4. And our slope, so this is like our y-intercept, and this is our slope. Which makes sense. We're going, see from here to here, we're going down 1 over 2. So Sean did not mess up the line itself. But what Sean didn't do is shade under, okay? Because it's y less than or equal to. So we have a solid line, but this less than or equal to tells us to shade below, okay? Or shade under. Shade below or shade under. So Sean's mistake was that Sean shaded above instead of below, okay? So that's all we have to say. Let's see, graph the inequality as shown, blah, blah, blah. So Sean, we could say here, shaded above. But, let me just move that over. But should have shaded below. Okay, that's it. That's fine to get part of the credit. Graph the inequality correctly on the same set of axes below. So I'm just going to borrow this piece here. I'm going to copy this. So we're going to copy this. So copy and then paste. Okay? Because I don't feel like rewriting that. So we're still going to begin here at negative 4. So 1, 2, 3, 4. And our slope is negative 1/2. So that's our rise over run. So I'm going down 1 over 2. Like this. Okay, and if I want to go backwards, I go up 1 to the left 2. And let's keep going like this. So now I'm going to connect these with a straight line. And I'll put the arrow, and we're shading under. Okay, so shade under. So this would have been, you know, obviously the way to go. And this will get you full credit. You don't have to label this because it's not a system. I mean, if you want to, just say like y is less than or equal to negative 1/2 x minus 4. And that just really plays it safe. Okay? All right, let's see. So let's pray we pass. I hope you all pass, for real. And I once again, I appreciate the support. from everybody here. It really means a lot to me. Like, yeah, I mean, I on one hand, like, I have to get through all the questions, but I do like to stop every now and then and say, like, just no, for real, like, thank you all so much. I recently, like, made a video on like 10 years on YouTube, and like seeing where the channel is now from where it started, it's like, it really does make me happy, like, to see like how big it's becoming. And it's like live streams like this. I mean it when I say, like, the live streams are my favorite days because I get to, like, talk to all of you and, you know, monitor the chat and like interact with my subscribers and stuff. So, like, thank you all so much. The most I'll ever ask, though, is, like, if you haven't subscribed, I know I'm like a broken record, like, please consider subscribing and spread the word, you know? Like, you know, you could tell your classmates about the channel if you think it's, like, really good. But, like, of course, only if you think it's good. I don't want to be like, oh, like, advertise my product for me if you don't think it's, like, worthwhile. Like, I think, like, word of mouth, it'll just catch on. But also, next, you know, June, you're taking the Regents again. If you're taking algebra, you're most likely going to be taking geometry next year or at some point. Then I'll keep doing these live streams and just, you know, I would hope you consider coming back for another one, because I you know, would hope that this is really helping. So, yeah. All right. Oh wait, common sense. You know, wait. Remember the one rule of the live stream. All right, I have it written on the side here, but please be respectful to everyone. All right. I know it's an emotional day, the day before the Regents, but those are, like, on my first day of school with my students, I have 2 rules for my class. It's like, be respectful to each other and work hard. That's it. I say be respectful to each other, me, and the classroom, and work hard. Like, those are the only things that'll ever, like, get me upset in the school building, if people aren't nice to each other. Like, if they're not nice to me, like, I'm like, oh no, it hurts my feelings, but, like, I'm older, so it's like, whatever. Like, but when they're not nice to each other, then I get really upset. That's the only time, like, I get, like, really angry as a teacher. But I don't take it personally. Like, I just try to use it as, like, a teachable moment if it happens in my class. It, like, inevitably every year someone's going to say something that upsets someone else, and I'm like, hey, like, would you have done anything different, like, if you could, and try to get them to learn something, because we all have to learn. So, you know. All right. So 35. How many questions are there on this? Let me just see. I think there's 37 on. 37 questions. All right. So let's see. What are we up to? Just going to get the rubric on the ready just to make sure everything is ready to go. Okay. So what we have here is a drama club is selling tickets to the spring musical. The auditorium holds 200 people. Tickets cost $12 at the door and $8.50 if purchased in advance. The drama club has a goal of selling at least $1,000 worth of tickets to the Sunday or Saturday show. Write a system of inequalities that can be used to model this scenario. Okay, so for this one, the auditorium holds 200 people, and there's 2 types of tickets. There's ones that are sold at the door, so I could call those X, and then the ones purchased in advance, I'll call Y. So the auditorium holds 200 people. So that would mean here that X plus Y, like however many tickets we sell in total, has to be less than or equal to 200. All right, because the auditorium only holds 200 people. So X plus Y has to be less than or equal to 200. But now they have a goal of selling at least $1,000 worth of tickets. So what they want is they want 12 times X, because it's $12 for the tickets sold at the door, plus it's $8.50, so 8.50 times Y. So this is how much money they earn. They want it to be at least $1,000. So that means it's going to be $1,000 or more. Okay, so this is, like, these you have to think about a little bit carefully, but it's greater than or equal to, because we want the total sales to be at least 1,000, which is 1,000 or more. Okay, so this, if I'll label this for you. This is like, you know, total number of tickets, and this is like total, like, sale. Okay, like total money earned. Okay, or I'll say like total, like, money. Make that $sign nicer. Total money collected. Okay, So that's, if you think about it, that's what you'll be going with. This part, like, it's not super obvious. Don't rush this. This is important to know. So now let's see. If 50 tickets are sold in advance, all right, so Y is advanced. So let's see. I'm going to just write on the side here, Y equals 50, because we labeled Y to be tickets sold in advance. What is the minimum number of tickets that must be sold at the door so the club meets its goal? Justify your answer. Okay, so for this one here, let's just think here. We have our system. My first instinct here is just plug into the system and see where it takes us. So what we have is we have x plus 50 is less than or equal to 200. So we have this. And then we also have 12x. I'll do that in a different color, so we could go back and forth. So we have 12x plus 850 times y is 50 is greater than or equal to 1,000. Okay, so if 50 tickets are sold in advance, what is the minimum number of tickets that must be sold at the door so the club meets its goal? So just plugging into this, I guess this one here gives us a cap that if we solve for x, x has to be less than or equal to 150. Okay, because remember, they're selling, there's 200 people in total that could be held in this auditorium. So whatever x is, it has to be less than or equal to 150. So if we're like, oh, my answer is 5,000, like for x, then no, that's not right. So now we go to solve this, and you could do the multiplication yourself, but we have calculators, so we might as well do this over here. So 850 times 50. So let me clear that. So 8.5 times 50 is 425. Okay, so far I have, let's see, we've got 12x plus 425 is greater than or equal to 1,000. So now subtract 425 on both sides. Like this, and now you've got 12x is greater than or equal to, and that's gonna work out to what, 575? But I'll double check. We do have a calculator, so no point in showing off. So 1,000 minus 425 is 575. Okay, so 575. And now divide both sides by 12. So x is greater than or equal to, and we're going to divide this by 12. And we get 47.9166. It looks like it's repeating. So 47 point, I mean, whatever, I'll just copy and paste this. Okay, just because I don't feel like remembering that. So we have 47.916. I'll even round like at this point, okay? You don't have to write out like a million decimal places. This is more than enough. So x has to be greater than or equal to 47.9167. But remember, think about what is going on here. X is the number of tickets sold at the door. So what is the minimum number of tickets that must be sold so the club meets its goal? You can't sell 0.9167 of a ticket, okay? So what is the minimum number of tickets that must be sold at the door so the club meets its goal? We would just say here 48 tickets. Okay, so 48 tickets must be sold at the door. All right, I'll even write for the club to meet its goal. For the club to meet its goal. All right, and if you even want to just plug in here and double check, like we said, 12 times, what do we say, 48. So just double check, make sure it goes over 1,000. So I have 12 times 48, so 48 tickets, plus 850 times 50 tickets sold in advance, and it's $1,001. We just meet the goal. If they had only sold 47 tickets, you could see, ready? 47 tickets, $989. They fall short of the goal. Okay, so that answer is looking good. Now we move on. Was it 36? All right, and then 37. So 2 more questions to go, and we are done. And where are we on time? Oh, 10:30. All right, we're making good time here. So Janice is asked to solve this equation. She begins by writing the following steps. So let's see, 64x squared. B squared plus 2b. Use Janice's procedures to solve for the equation x. So what did she... Line 1 to line 2. Sorry, this is where my thought is going. So 64x squared became b squared. So square root of both sides. The square root of 64 is 8. Square root of x squared is x. Square root of b squared, what does it say is b? So she made a substitution. She let capital B equal 8x. Okay, so use Janice's procedures to solve. So here I would just say 0 equals b plus 3 times b minus 1. So set each factor equal to 0. Set b plus 3 equal to 0. And set b minus 1 equal to 0. And you solve this one for b, and that tells you b equals negative 3. And this one tells you b equals positive 1. But remember, b is equal to 8x. Okay, so I would even say that off to the side here, like b is equal to 8x. So then you could replace b with 8x equals negative 3. And then here you have 8x equals 1. And now when you solve for x, we have x equals negative 3/8. And dividing here for this one tells us x equals 1 over 8. All right, I'll just put an arrow here so it's like kind of matching how we represent it. So that seems right. What I would do to be safe, all right, is just to be like confident here. Negative 3/8 is this decimal here. So what I would do is I would plug it into the original. I would say, and I'm going to show you a little trick. Store it as the letter A. Store alpha math. Because now every time I write alpha math, the letter A, it's that decimal. So I have 64 times that decimal squared plus 16 times x, but we're going to put our answer, negative 0.375, and then minus 3. And it gives me 0. All right, so like this answer is looking good. I'll just check the rubric here to make sure I'm not misleading people. So negative 3/8, yeah, or 1/8 is good. Cool. And now we just have to write an explanation. Explain the method Janet used to solve the quadratic equation. So we could just say Janice substituted like b equals 8x. Okay, so she substituted for 64x squared and 16x. So now we just have to write, yeah, it's kind of annoying. We just have to write it in words though. So let me just zoom out a bit so we could like look at what happened there. So I could say Janice let capital B equals 8x and substituted into the equation 0 equals 64x squared. I'll even say let b equals 8x and substituted it into the equation 0 equals 64x squared plus 16x minus 3 to get 0 equaled b squared plus 2b minus 3 and then factored. Okay. So yeah, that basically like captures it. Okay, that's exactly what Janice did. She substituted b equals 8x into the equation and got this. All right, and then factored. All right, but that's all she did. So yeah, that would capture what Janice did, because explain the method Janice used to solve. The annoying part here though is she didn't actually solve it. She just got up to this step. We actually solved the rest. So we really just have to explain the method Janice used. If you want to like be safe here, you could say then like afterwards like then I like found the roots. Just in case they're like, you didn't see it all the way through. Then I found the roots in terms of b, subbed b equals 8x, and then solved for the roots in terms of x. All right, like that would be like really extra, but I would just write that maybe to be safe. Because I'd be like what do they want me to stop? Because this is kind of a sloppy question, like to critique it a little bit. It could have been more like precise with how they were asking it. All right, let me just see. So the last question, part 4, 6 points. All right, so this is we finally made it to the end here. And I'm just gonna have the rubric on the ready. So just to make sure everything is scripted nicely here and ready to go. So for a class picnic, so it's a system of equations. 2 teachers went to the same store to purchase drinks. One teacher purchased 18, so here we go, 18 juice boxes. So let me just get it back in pen mode. 32 bottles of water and spent this much money. And the other teacher purchased this much juice boxes, this much water, and spent this much. So juice box is J and a bottle of water is W. Write a system of equations to represent everything that just happened here. So it's 18 juice boxes is J plus 32 bottles of water is 1992. And then the second equation would be 14 juice boxes plus 26 bottles of water is equal to 1576. All right, so just writing this equation here is like you have to be able to do this. Otherwise, you're getting it's really going to be hard to get any credit here. But let's see what they say after this. So now Kara said the juice boxes might have cost 52 cents each, and the bottles of water might have cost 33 cents each. Use your system of equations to justify that Kara's prices are not possible. Okay, so here, what we want to think about is, I'm trying to see how they're representing this here. So 52 cents, they're going to write it in terms of dollars, so 0.52. All right, so the juice boxes, so let me just color code this even more. So juice boxes, 52 cents, and bottles of water, 33 cents. So why are those prices not reasonable? Well, if you plug in, let's see, 18 times the cost of a juice box is 0.52. Plus, we have the bottles of water, 33 cents. So 32 times 33 cents. And now calculator. We're going to use the calculator for this part. So 18 times... And what they do sometimes to be annoying is the first equation works and the second one doesn't. And you're like, oh no, I got to do this again. So I feel like that's going to happen here. They're going to be cruel to us. Yeah, see, 1992. That was not nice. Okay, so 1992. So that means we got to plug it into the second equation. So this, but now 14 times 52 plus 26 times 33 cents. So you see we're plugging in juice is 52 cents, water is 33 cents. And now let's see what we get. Okay, so yeah, that I had a feeling that was going to happen, but just in case it didn't, it was like worth finding out. So 14 in front of the 52 now. So 14 plus 26 and is 1586. Okay, so this is 1586, which is not equal to 1576. Okay? So use your system of equations to justify. So justify just means show work. So this is the one here that really does all the justification. Let me see. I'll move these closer. You know, let me do this. I'll move that up a little bit. Okay, so now this is the one that establishes it, that her prices are not reasonable. Okay, let me see, there we go, that's better. So that's the line, okay? So you say therefore, oh, you wanna know something cool? Therefore, although algebra teachers might not know this, this means therefore, but whatever, I'll write the words, okay? If you wanna know, this symbol means therefore. So therefore, Kara's prices are not possible. Prices are not possible. Right? We don't have to explain. Right? If you want to be safe, though, you could say because the second equation is not satisfied, but the not equal to is the justification. Therefore, Kara's prices are not possible. I will now erase the symbol for therefore. Okay, so now I'm going to copy and paste this because the third part we actually have to solve the system for the actual prices. So let's go ahead and do that. And they probably want us to do it algebraically. Ooh, solve your... Wait a minute. Can I really do this without algebra? All right, I'm going to do this algebraically because... Solve your system. So solve, they want us to... I'm going to show the work because something tells me if like I try to be like, haha, I gotcha, then that's not going to fly. But if I had the option here, like I would, if time is like not an issue, like let's say I have like 45 minutes left, which, you know, this live stream, whatever time I started, how long has it been running? 2 hours and 16 minutes. Yeah, I have time to do this. Like there's 3 hours to do a Regents. So even with me talking and all this, you know, we still didn't like run out of time here. So 18 J will be X plus 32 Y will be W, and it's 1992. Okay, and then 14X plus 26W. I mean, they didn't say algebraically. So, 17 over 25, of course. Is there a way for me to... Let me do something. So let me go back to the main screen. Mode, I'm going to switch from auto to decimal. Let me pretend like I don't want fractions. I want decimals. Because don't write your answer as a fraction. It just doesn't look as nice. All right, let's try that again. 9, 2, next. Oh, it's still saved. It's still a decimal. All right. So 17 over 25, 6 over 20. I mean, just do times 4. Let's see, 68 cents and 24 cents. Yeah. So like in my, calculator, and let me actually, oh, whoops, move this over here. Yeah, so those values, well, I don't know why I should just copy and paste that. So using the calculator, I mean, if you just wrote like I use the simultaneous whatever solver, like I feel like it's gonna say algebraically. Like this one here, it's like I will like look at the rubric before we end this live stream to see. But X was W. W equals 17 over 25. You could punch in a calculator, is gonna give you this. Okay, and then Y is, oh, I'm sorry, that was J. Yeah, so that was J. Let me just fix that. J is equal to 0.68. And then W is equal to times 4, 0.24. Okay, now the reason why I would want to do this first is I want to know what we should be aiming for. So this one, this is not nice numbers. Let me see. If I divide by 2, I get 9, 16, 7, and 13. So 9 and 7. So solving this algebraically is not going to be nice. Like elimination will work, but I'm almost tempted here to use substitution because like we have to multiply by some crazy numbers. Is there a nicer way? All right, I guess, let me see. I'm just thinking out loud. If I have to solve for one of these. Yeah, see, this is like so nice already. Like it's already solved. Like, hey, I used the calculator. These are the values. I'm done. No, elimination works, but it's just really not going to be pleasant. And if we don't do elimination, we have to do substitution. So let's think about this. Elimination, if I divide that by 2, the top, I'm pointing and no one can see what I'm pointing at. Like what I'm imagining in my head is like I divide this by 2. So I'm thinking like, all right, 9J plus 16W equals. And then I divide that by 2, and I have like 7j plus 13w equals. And it simplifies it, but now I have to multiply this by like 7 and this by like -9. So, I mean, you know what? Whatever. I'm just going to do this like... so how about I use elimination? We have a calculator, so the numbers could be big. Oh, let me just fix this. All right, you know what? Whatever. That's what we're going to do. I'm going to multiply the top by 14. So the numbers are going to be absurd. And I'm going to multiply the bottom by -18. Because then the j's will eliminate. All right, so I'm just going to do some of this multiplication ahead of time. So if we're doing this algebraically, 14 times 18, I'm just going to write out all the products that we need. 32 times 14. And then 1992 times 14. I mean, for a situation like this, they should totally let us just use the calculator here. But we'll see. Like, and when we get to the rubric, if it had to be algebraic. Because if it has to be algebraic, then I kind of have to do this, which is like really annoying. But whatever. All right, so I'm just doing the multiplication ahead of time. And now if I do the 18, so 18 times 14 we still have is 252. So I'm not going to do that twice. 18 times 26. I know it's negative, one of them, but whatever. I'm just going to worry about that later. And then 18 times 1576. Okay. So now I copy and paste those two. So this would be something I'm just doing on the side. I'm just putting it here, though, because I don't feel like doing this one at a time and then suffering. Okay. So if we're doing this by hand, because I don't want to like not show how to do any of this by hand. So 14 times 18 was 252. So I have 252. Let's make that a little neater. 252 times j plus 14 times 32 was 448. So 448w equals, and when I multiplied 1992 by 14, we got 278.88. And now this one we multiply by negative. So everything's going to be minus in this one. So for that one, we're going to have negative 18 times 14. 18 times 14 was 252. So now I have minus 252j. So in a moment when we add, these will eliminate. 18 times 26 is 468. So I have minus 468w equals. And now for this one, 18 times 1576 was 283.68. But we multiplied by negative 18, so this will be minus also. So now we could add these equations together, and these will eliminate. And then 448w minus this is going to give us minus 20w. And this equals, so now I could just work that last part out. I could just do the rest of the arithmetic we need. Just to double check, 448 minus 468 should give us minus 20, and it does. And then we have 278.88, and then minus 283, and then 68. And that gives us negative 4.80. Okay, so negative 4.80, and now divide by negative 20 on both sides. So W equals, moment of truth, W equals 4.8 divided by negative 4.8 divided by negative 20 is W equals 24 cents. Okay, cool. So that's this. And now to solve for the price of the juice, now we can just plug this into any equation. So I'll just plug it into this one before we started, multiplying it up and stuff. Or I can even plug it into this one because the numbers are smaller. So it doesn't matter. Either one's going to give us the right answer. So now we have 14j plus 26 times 0.24 equals 1576. Okay, so I'm just going to do the equation stuff in one step here. So we're doing 26 times 0.24. And then eventually this, we're going to subtract from 1576. So 1576, we're going to be subtracting 6.24. Okay, so I'm just going to screenshot those last two. I know I'm doing so many screenshots here. It's just I really don't want to go back and forth too much. It's like, yeah, not the most pleasant thing here. So now, all right, this is the end. 14j plus this times this is 624 equals 1576. And yeah, 1576. And now minus 6.24. Oh, I should have divided 2. That was silly of me. 14j equals 952. Now divide by 14. Okay, then we have what j is. So j equals, so one more move, and we have our value here. So this divided by 14 is 68 cents. Okay, so it checks out. So they ask us to determine the cost in dollars of each juice box and bottle of water. So I would just write it out formally. So what are they asking here? Of each juice box and each bottle of water. So I'll just say here off to the side. So bottle of water is like, I'll just say here is 24 cents. And a juice box is 68 cents. Okay, so yeah, one bottle of water and one juice box is this. Okay, so that, yeah, just about wraps that up. But we should totally be able to just use the calculator for this. That seems like an unnecessary amount of stuff. Let me look at the rubric for this question though. So let me just see here. If we go to the rubric, and I'll just scroll. Here we are. Oh, correct work is shown to find this. Let's see. Let me see if they say you're not allowed to use algebra. I mean, like they don't say anything about some other method being used. So yeah, it's dicey, but I would just say like, you know, do the math and just get there. All right, where are we? So other questions in the chat. Let's see. Oh, I would get a 101 on this test. I appreciate that. No, you know what? I don't, if I took like a bunch of Regents in a row, I don't claim I would get 100 on everything. You know, it's so easy to make a silly mistake. But to be honest, I would personally I would just do a lot of Regents exams and make sure I'm sharp. If I don't practice and I just show up cold to a Regents, yeah, I'm confident I would break in the 90s, just about every time. But to get the 100, I would take it very seriously. I would be in student mode and be like, all right, it's time to get ready for a competition. Yeah, I've been doing math for a long time, so I'm making it look oh, it's somewhat easy, but that's only because I've done it for so long and I'm still doing it. But if I took 5 years off and I showed up to an Algebra 1 Regents or Geometry Regents, it'd be rough. It's so at Demario Harrison, I wouldn't say it's necessarily easier. It can be easier, but it's not guaranteed to be easier. It's up in the air, to be honest. There's a chance it could be easier. There's a chance it could be harder. Most people vote that it's harder, but I don't know. I don't want to say that's definitely going to be the case. So yeah. Oh, hi at Noor Fatima. Thanks for joining here. So any last minute questions here before I sign off? I definitely want to clock out by 11 because I'm very tired and I have to stream in the morning. But any last minute questions while I'm here? Just more advice questions. I'm not going to do any more math. But I will say to everybody, good luck. All right. And once again, thank you so much to everybody here. I just appreciate, everybody who joined, especially anyone who comments or subscribes. I know not everyone likes to comment. Some people just like to watch, and that's totally fine. But I just appreciate that you're, doing so much for this channel by you being here. If there was nobody here, it would be it's not as enjoyable for me. 31 people on right now, almost 600 watched in total. It's just really awesome. Any calculator tips? I mean, just know how to reset a calculator, for sure. Like just looking at this, like knowing like, all right, second memory 712, like resetting it, go into mode and making sure like you go from auto to decimal. I'm also only showing TI. I'm not going to show Casio. I don't know Casio how it works. Down the line maybe if it takes over, but Texas seems to be the more popular calculator. You know, knowing how to graph stuff in the y equals, like, all right, y equals x plus 5. Second graph to go to the table, graph to go to the actual graph. Things like second window, auto over to ask allows you to enter values in, you know, custom values. Like, oh, what's going on at 0.5? Or maybe I want to count by fives, like 5, 10, 15, 20, and so on like this. So it allows you to make custom tables. So, you know, not the same questions as June. They're all going to be different. Square root is second x squared. So like square root of 9 is 3. Okay. So those are really the main functions you got to know. Absolute value, if you don't know that one, is math, go to the right, and ABS. Okay. So like the absolute value of 5 is 5. They might have you graph absolute value. That's why it's good to know. So if you go to y equals and you do absolute value of x, you'll get that classic V shape. Okay, so Algebra 2 review I might do super early in the morning, but I don't think I'll be able to do like a full test. I did a live stream for it in June, but just the multiple choice. So like maybe I'll just do the free response. But I do have to do geometry. The polynomial thing is apps number 9. Okay, so I'll do it one more time. Apps polynomial simultaneous 2. So on my calculator it's 9, and then it's number 2 here, the equation solver. So in Algebra 2 for that Regents, they do like a 3x3 system, so it's good to know. Where do you substitute? Oh, so if I press next, like you just, let's say it was like, all right, 3x, so I press 3, enter, and let's say it's subtract, so minus 5y equals 10. It's going to be ridiculous, whatever I get here. 2x plus, I don't know, 4y equals 3, and then graph. Oh, wow, those numbers weren't so ridiculous. Like, that's my solution. Okay, so it's helpful to know. Just remember this. All right, one last thing I'll say before I call it a day is when they tell you to solve. So let's see. Where's one where they tell you to solve? Oh, all right. So something like this. So algebraically, they're like, hey, do this algebraically. And you say, no, thank you. I don't know the algebra. Okay. I'm not telling you to do this like for all your questions, but if like your goal is to pass and you don't know how to do this, you know, like the calculator is a nice tool to like kind of bypass how to do the math. So like if I went to the y equals here, so now I press second mode, I quit, and I go to, and I just write this in like, all right, x minus 3 squared minus 49, and I press graph. Okay, like notice here, like my calculator, it runs out. So you'd have to know to go to window, let's say, and I make my biggest x value 15. Now what that accomplishes is now I could see more of the picture. Okay, so if you go to the window, you could mess around with your smallest and biggest x value. But now when I do second trace 0, so let's say I go here. I press enter before, I scroll to the right, I press enter after, enter a third time. See, I get x equals 10, and that was one of my answers. So if I solve this and I don't do any algebra, I'm like, no thank you, I'm using the calculator. I'll show you all for question 31. I will copy and paste the rubric real quick. So let me see, can I just add a page here? Wait, that might have, let's see, is this? Nah, you know what? I wanted a fresh page, so whatever, I'll just screenshot it over here. So I'll show you like what they use to grade these things. So this, let's see, no, this one here I'll just highlight. But yeah, this will be the last thing. So you write the answers, but use something other than algebra. Or you just write the answer, but you don't show any work. You still get a point. Okay, so if they tell you like, hey, you have to do this algebraically, the saddest thing I see is like when students just leave it blank. I'm like, no, like you could use a calculator, but you're not going to get full credit. Like obviously, I always try to get my students to aim for the highest score possible. And I'm like, no, I want you to learn the algebra. But if you can't do the algebra, like get something. It's better than like taking the 0 on the question, because too often, like I see it even in my views, like people watch my multiple choice video, but then they don't watch my free response. They're like, no, I'm just going to pass this in the multiple choice. I'm not even going to try the free response. I'm like, no, you could still treat the free response like it's multiple choice. You're not going to get full credit, but it's going to buy you those extra points that you need to pass. So, because I have a whole range of students here. Some people just want the 65, and some people want like the 80, some people want the 90, some people want the 100. So it depends on what your goal is. If you want a 90 up, you got to be able to do like everything. If you just want to pass, then like pay attention to stuff like this. Okay, know what the test is like is a big part of it. All right, so it is 11:02, so I'm going to sign out. But thank you all so much once again for swinging by. This will be saved on my channel, so you can watch the replay if you missed, like, you know, the first 2.5 hours. But yeah, once again, thank you all. Good luck to all of you. It's normal to be nervous, but remember, you're going to use that nervous energy and like put it to work. Okay, it's normal to be nervous before like the big day, but when you get there, just say like, all right, I'm nervous, but like let's just do this. Like just try to hype yourself up. Okay, don't focus on what you don't know, just do the stuff that you can. All right, so try not to get too, you know, wrapped up over that. Yeah, some algebra 2 stuff. I'll put something together in the morning, because I know the algebra 2 test is at like 1, so I could have like just a brief chat about algebra 2. I'll kind of just like, yeah, talk algebra 2 theory, like, and stuff. All right, but take care, everybody, and once again, good luck and thanks for watching. So